Hi, this is part 9 of the math journey, and yeah, let's just jump right into it. This is where I left off. Yeah, let's go decimals, and then, okay, subtracting. So yeah, I tried to play the first video on last time, and figured out how to start. So I'm gonna do the subtracting today, and hopefully I could finish all of this today. Yeah, let's just go.
Minus
Recording.
1.2 is. Pause this video and do some more examples subtracting decimals. So let's say we want to figure out what 2 minus 1.2 is. Pause this video and see if you can calculate this. So there's multiple ways to tackle this. One way is you could say, look, this is the same thing as 2 minus 1, 2 minus 1 minus 2/10. This is 2 minus 1 and 2/10. So you were subtracting 1 and we're subtracting 2/10. Now 2 minus 1 is pretty straightforward to compute. 2 minus 1 is going to be 1, and then we need to subtract 2/10 from that. So 1 is the same thing as 10/10. We could say this is 10/10. 10, let me write it this
10
way.
tenths
10
minus 2 tenths.
tenths.
8 tenths.
And we're going to subtract 2/10. What is that going to give us? Well, that's going to give us, if we have 10/10 and we take away 2/10, that's going to give us 8/10. Let me write it down here. 8/10, which is the same thing as 0.8 or 8/10. One way to think about this is if you're subtracting 0.2 from 1, if you view this 1 as a 1.0, instead of expressing this as 1, 1 and 0/10, we are thinking about this as 0 ones and 10/10. And when you think about it as 0 ones and 10/10, well, 10/10 minus 2/10, it's easier to then think about, well, 10 of something minus 2 of something is going to be 8 of something. It's going to be 8/10. Now, we can also visualize this on a number line. So, for example, let me draw a number line here. And so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 2. So we're starting at 2, and we're subtracting 1 and 2/10. So one way to think about it is we first subtracted 1. And then we subtracted 2/10, and that got us to the point 8/10 on the number line. Another way to think about this, and the whole point here is to see multiple strategies and for you to think about what strategy you like the most and to realize they all get you to the same place if you're thinking about it in a reasonable way, is you could use what's the difference between 2 and 1.2. So 1.2 sits here on the number line. So what's the difference between 2 and 1 and 2/10? Another way to think about it is, how many tenths do you have to add to 1 and 2/10 to get to 2? Well, if you've already got 2/10, you need to add another 8/10 to get to the next hole. So you have to add 8/10, or you have to add 0.8. So the difference between 2 and 1.2, is equal to 0.8. Let's do a few more examples that get a little bit more involved. So let's say we want to calculate what 3.8 minus 1.5 is. Pause the video and see if you can calculate this. Well, just like before, we could view this as 3 minus
I guess this is
1. So we're subtracting the 1s plus 8/10 minus 5/10 minus 5/10 minus 5/10. Notice we have 3 and 8/10 minus 1 and 5/10 minus 1 and minus 5/10. And so now we can figure out, okay, 3 minus 1, that's just going to be equal to 2. And then 8/10 minus 5/10, well, that is 3/10. And so this is going to be 2 and 3/10, which of course we could write as 2.3. That seemed pretty straightforward. Let's do one that's a little bit more involved. Let's say we want to calculate 4 and 5/10, or 4.5, minus 2 and 8/10, or 2.8. Pause the video and see if you can calculate this. So you might want to do the exact same thing. You might say, okay, well, this is the same thing. Let's think about the ones.
So
this is 4
I got 1.7
minus 2 plus 5/10 plus 5/10 minus 8/10 minus 8/10. 4 and 5/10, 4 and 5/10 minus 2 and minus 8/10, minus 2 and 8/10. That's exactly what we have up here. And you'd say, all right, 4 minus 2, that is 2. But then you get to 5/10 minus 8/10. And there's multiple ways to tackle this. But you might say, well, how do I take away 8/10 if I've only got 5/10 here? And there's a bunch of strategies that you could think about. You could say, hey, what if I can get some more tenths here? So this is 5/10 minus 8/10. What if I could get some more tenths here? And the best way I could think of it is like, what if I were to break up these ones? Because 1 is 10/10. So I could view a 2. I could view a 2 as 1 plus 1. Or I could view this as 1 plus 10/10. 10/10. So if you view a 2 as 1 and 10/10, you can then just add those. You can then figure out what is 10/10 plus 5/10 plus 5/10 minus 8/10 minus 8/10. What is that going to be? Well, this is a little bit more straightforward. 10/10 plus 5/10 is going to be 15/10. And if you have 15/10 and you take away 8 of them, you're going to be left with 7/10. So this gets us to 1 plus 7/10. So all of this, when you compute it, that is 7/10, which I could write as 0.7, which is equal to, so this is equal to 1 and 7/10. Now there's other strategies that you could do here. One strategy that, and this is the one that I typically do in my head, is I write this as 4.5 minus 2.5 minus 2.5 minus 0.3, or 4 and 5/10 minus 2 and 5/10 minus 3/10. Now why did I write it this way? Because I find this pretty straightforward to compute, and then once I get that answer, I just have to take away 3/10. So for example, well, if I have 5/10 here and I'm taking away 5/10, those are going to knock each other out. And so I'm just going to be left with 4 minus 2, which is going to be 2. And then I have to take away the 3/10. Then I have to take away the 3/10. So this is a pretty straightforward way of doing it in your head. So what's 3/10 less than 2? Well, you can visualize a number line in your head. Well, that's going to be 1 and 7/10. 1
insane
and
number line in your
7/10.
head.
And if this feels strange how I got, I wrote 700s, 1 and 7/10. And if this seems strange how I got there that fast, just think about this. This is the same thing as 1 plus 1 minus 3/10. And this 1 right over here is the same thing as 10/10.
Oh, isn't that the same
And so
thing?
10/10 minus 3/10. That over there is going to be, 7/10. So it's going to be 1 and 7/10, which is what we got before. So the whole point here is to appreciate that there's multiple strategies for subtracting decimals. Some that you can do a little bit more automatically, but it's really good to think about what's going on in your head. And some strategies are actually better in your head than on paper, or at least more easy in your head. So let's say we wanted to compute 8 and 38/100ths minus 4 and 54/100ths. See if you can pause this video and figure it out on your own. So there are multiple strategies for doing this. I'll tell you the way that my head likes to do this. I would view this as the same thing as 8 and 38 hundredths. And then I would subtract 4 and 38 hundredths. The reason why I pick 38 hundredths is that will cancel out. It'll take away these 38 hundredths. And then I still have to subtract a little bit more. If I already subtract 38 hundredths, well, I have to subtract a total of 54 hundredths. So let's see, 54 is how much more than 38? And I am doing this in my head as I speak. Let's see, to go from 38 to 48, I need 6, and I need 10 more. So I need to subtract another 16. I need to subtract another 16 hundredths. And how did I think about that? Well, 54 is 38 and 16. So if I'm subtracting 54, I could break that up. I could subtract 38 hundredths, and then I could subtract 16 hundredths. Why did I pick 38 hundredths? Because it matches up with this. And so if I say 8 minus 4 is going to be 4, and then I have 38 hundredths minus 38 hundredths. Well, those are just going to cancel out with each other. So this minus that is just going to be 4. And then I'd say 4 minus 16 hundredths. So how do we think about that? Well, you might be able to do this in your head at this point. You might say, okay, well, I have to go 16 hundredths less than 4. That's going to be 3 and 84 hundredths. Or you might want to just break it up. You could say, okay, 4 is the same thing as 3 plus 3 plus 100 hundredths. Hundredths. And then I want to take away minus 16 hundredths. Well, 100 minus 16 is 84. So this is going to be, this part right over here is 84 hundredths. I'll write it out. Hundredths, which I can write as 0.84. And 3 plus 0.84, well, that's going to be, this is going to be equal to, and we figured it out already multiple times, 3 and 84. 3 and 84 hundredths. Now, as I said, there's multiple ways that we can try to tackle this. For example, another way that I could do this one right over here is I could say, all right, let me do the ones. So I'd say 8 minus 4. 8 minus 4 plus, let me try to do the tenths. So I could have 3 tenths minus 5 tenths, 0.3 minus 0.5, and then I would have the hundredths. So 8 hundredths minus 4 hundredths. So plus 8 hundredths minus 4 hundredths. Now this is pretty easy to compute. This is pretty easy to compute, but what about this? I don't have 5 tenths to take away. Well, what I could do is, instead of having an 8 here, I could take 1 away from it and make that a 7. And so I have 1 that I can regroup someplace over here. I can reorganize it. So I could do this as 7 plus 10 tenths. And so I can take those 10 tenths. I could take those 10 tenths and add them right over here. So let me rewrite this. I could rewrite this as 7 minus 4 plus 10 tenths plus 3 tenths. And let me just write it all as plus 3 tenths. I'm mixing different ways of writing it this way, but that might be good. Minus 5 tenths. And then this part I could just compute. This is plus 4 hundredths. Let's 0.0, let me do that color. Plus 4 hundredths. This is right here is going to be 4 hundredths. Now what is this going to be? 7 minus 4 is going to be 3. 10 tenths plus 3 tenths. Just the right color. So this is going to be 3. And then 10 tenths plus 3 tenths is 13 tenths. Minus 5 tenths is 8 tenths. And then I have 4 hundredths. So once again, 3.84. 3 ones, 8 tenths, 4 hundredths, or 3 and 84 hundredths.
Cool. Early reporting.
We need to calculate 9.005 minus 3.6, or we could view it as 9 and 5 thousandths minus 3 and 6/10. Now, whenever you do a subtracting decimal
Oh,
problems, the most
crap, this is
important thing, and this is true when you're adding decimals as well, is you have to line up the decimals. So this is
like like
9.005 minus 3.6 minus 3.6. So we've lined up the decimals, and now we're ready to subtract. So now we can subtract. So we
yo,
start
this
up
is
here. We have
insane.
5 minus nothing. You can imagine this 3.6 or this 3 and 6/10. We could add 2 zeros right here,
Uh,
and it would be the same thing as 3 and 600
4. Oh
thousandths, which is
shit.
the same thing as 6/10. And when you look at it that way, you say, okay, 5 minus 0 is nothing, and you just write a 5 right there. Or you could have said, if it had a nothing there, it would have been 5 minus nothing is 5. Then you have 0 minus 0, which is just 0. And then you have a 0 minus 6. And you can't subtract 6 from 0, so we need to get something
Yep.
into this space right here. And what we essentially are going to do is regroup. We're going to take 1 from the 9. So let's do that. So let's take 1 from the 9. So it becomes an 8. And we need to do something with that 1. We're going to put it in the tens
Tenth
place. Now
place.
remember, 1 whole is equal to 10
Tenth
tenths. This is the
place. Yeah.
tens place.
Ten
So then this will
tenths.
become 10. Sometimes it's taught that you're borrowing the 1, but you're really taking it, and you're actually taking 10 from the place to your left. So 1 whole is 10 tenths. We're in the tens place. So you have 10 minus 6. Let me switch colors. 10 minus 6 is 4. You have your decimal right there, and then you have 8 minus 3 is 5. So 9.005 minus
Hey, you got 10.
3.6 is 5.405.
So let's try to calculate 39.1 minus 0.794. And so pause the video and try this on your own. All right, I'm assuming you've given a go at it. So now let's work through it together. So I'm going to rewrite this as 39.1 minus, I'm going to line up the decimals so that I have the right place values below the right place values,
Yo, I got
minus, this 0 is in the
38
ones place, so I'll put it in the ones place,
600.
0.794.
No, not hundreds, thousands. 38 point
And now we're
306
ready to
thousands.
subtract.
Yeah.
Now, how do we subtract 4 from nothingness here and 9 from nothingness
Nothingness.
here? Well, the same thing as nothing, the same thing as nothing is a 0. And so now we can start to think about how to subtract. Well, we still have the problem. Well, we're trying to subtract 4 from 0, so we're trying to subtract 9 from 0. So what we could do is take this 1/10 and try to regroup it into the hundredths place and the thousands place. So let's think about this. If we make, actually, that's not actually going to solve our problem. Well, we could do it, but then we're going to have 0/10, and we're still going to have a problem here. So actually, let me go to the ones place. So let me get rid of a ones. So that's 8 ones, which is going to be 10 tenths. So that's going to, now we're going to have 11 tenths. The 10 tenths from here plus 1 is 11 tenths. Now let's take one of those tenths so that we have 10 tenths and give it to the hundredths. So that's going to be 10 hundredths. And now let's take one of those hundredths, so now we have 9 hundredths, and give it to the thousandths. So that's going to be 10 thousandths. Now we're ready to subtract. So 10, let me do this in yellow. 10 minus 4 is 6. 9 minus 9 is 0. 10 minus 7 is 3. We have our decimal point. 8 minus 0 is 8. And then we have 3 minus nothing is 3. So we're done. 38.306.
Next article. This article is designed to help you learn how to subtract decimals better than jumping. Probably go from ways to more different. Only there are hit stuff. Yeah, let's start with subtracting tenths. Beautiful. Let's move on to problems with numbers and tenths. Oh shit, it's insanely hard. Okay. Excellent. Let's move on to some larger numbers. Oh shit, crap, it's hard, man. Oh shit. no regrouping happening at the moment. It's just gonna be like 1, right? Oh shit! Wait, what? Yo, why? 78 minus 1 is like 3, right? Then 0.5 minus 4 is like just 1. Yo, oh shit! It's 7. It's the same. Am I supposed to say 10? No. Okay. Oh my gosh, I'm so weak. Okay, from 61 to go, we get 9. The rate we have like 17.1. No? No. Okay, cool. Rock and let's do more the way around this one now. What's this? Let's say this is 5, and then it's gonna be like 4. But it's only like 4.9, so yeah, and then 33 minus 0.8. What's this? Say 17, then 16. Yo, this is hard. Good luck, this one. What's this? Holy shit! Oh my god. Okay, it's 2. Okay. If this is 12, then we got like 13. 1, 3. Oh no. 1? Oh shit. Why am I saying 13? Oh shit, this is hard. Oh, so if this is 15 minus 12, then we're gonna get 3. But it's just 0.9, so it's gonna plus 1. And then the 2, so 3. Okay, cool. So this one's like 9. Oh shit, it's gonna drink with what's gonna happen. Let's say 61 to the other side, and then we're back to 16 minus 7, 9. But 0.9 means 61 minus 59. It's gonna be 9. Oh, okay. It's a lot of problems there. Holy shit, it goes up to 8. Subtract hundreds. This is 0.4, then I'm gonna get like 0.24, that's 0.1, so 0.93. So let's go from 34 to 60. We add like 30, we get 60, and then 5. 9. From this is 30.3, and then we're gonna add 60, and then 4, 7. Holy shit, so good. Great, let's move on to problems with own numbers. Thanks. Congrats. Oh gosh, this is hard. Okay, let's explain this. Oh shit, no. 4. Let's say 0.67. No? Oh shit. You need 0.28. It's very left here still. Or 4.12. 2.28. Then 13 point is this 23. Sweet, let's finish with some more challenging problems. Oh shit, this one's real challenging. So this is 3, but not really. So 2.65. Mm, 3. This is probably not 4 minus 7 to 87. 13 minus 5, 8. Oh man, I got it wrong. Okay. Let's see. If I need to get like a 10 from this guy, give it to the guy, so we have 94 minus 7, it's gonna be 87, right? And then we have 13 minus 15. So it's like 8, and then we're gonna bring down 3. What's wrong? What the hell? Okay, 95. I'm gonna solve paper. Oh shit, it's not because it shouldn't be there. Is it? Let's see, let's see. Let's see. No, 3. Yo, I got 87.83. That's insane, what the hell? Let's try again. 95.3 minus 7.53. That's 0 on the 100, so we're gonna borrow. No, oh shit. Wait, what? Oh yeah, it's my mistake. My mistake. My mistake. My mistake. It's 87.7 to 7. I bought bring down 3. Even though it should be subtracting the nothingness there. Ah, crap. Alright. That's where my mistake was. 35 minus 5.6 minus 9.8. You have 16 there. 14. Like 14 as well. 2 over there. 8, 9, 5, 14, and 5 again. 1, 15, 8. Next, do it. No, we're gonna do the thingies. Oh shit, it's a lot. Oh my god, I don't want this thing. Come on, this was hard. Oh, alright. Good. Uh, 6. $17, right? 75. 3. Oh. Oh shit, it's hard. Or not, I mean, I just, it's not regrouping, so 7, 4, and 2. Whoa! Why did it say 7, though? Yo, 8 minus 3 is like 5, man. Why did it say 7? Insane. Okay. 2, 7. Oh shit, it's gonna be some broken thingy happen again. 7? No, I'm not sure. Okay, cool. Okay, so 7. Then network's gonna knock each other out. Okay, so let's say 3. this, let's say, just like 21.9. Oh shit. Thank you. 9. Holy shit. So if this is like 62, then the 80 to minus 62, like, but then it's actual 63, so it's 19. Then minus the 9. I shouldn't be bringing it down like that. It's wrong. It should be like 8, 18, 1, no? Yeah. Okay. Yeah, I'm seeing now 5, 6, 3. Oh shit, I don't want to make a mistake. Dude. Okay, this is gonna be 4.1. Holy shit. It's not 4, it's 5.1, dude. Okay, 92, then 7. Oh yeah, this is where I'm gonna make a mistake. It's doing in my head. 3. Oh shit, it's 1. Yo, wait, it's not 10, it's 11. Oh, so this is like 18. Oh shit, it's 42. Oh my god, I hate this. Oh my god. Now I have to redo everything again. You know what? I'm not gonna do it in my head anymore. I'm just gonna I will do it everything with 7. Yo, my handwriting sucks. 80.0, right? Comes to 4.2. We got 10 here. That it becomes like 10, right? And then 9. It's going like 7, 8, 5, 5, 25, 4, 8, 0, 11, 7, 3, 4, 3, 4. Okay, 93.5 minus 16, 0, 13 here, 7, 8, 7. No, seriously? No. 13, 7, 16, 9, 8. 8 minus 7. Yo, what the hell? 93.5 minus 16, right? We have 5, so it's 13, plus 8, plus 7, 7.5, y'all. Why is this 0? Oh my god, we did that. Yeah, keep on practicing. Let me keep on practicing. 57.3 minus 37.6 becomes 13. Get 1 that guy. 1 that guy's gonna 16. That's like 7. This like 9. Like 19.7. 91 minus 10.2. This becomes 10. This becomes 9. 1. So we have like, yo, what's this? We have 8.9.8. Oh shit, it's for real. It's for real. I don't want to do the whole thing again for the third time, fourth time. Times 10.20. This comes 10. This comes 0. 8. Yeah, it's from 0, 10.8, man. Okay, we're going. Let's do it again, man. So we got 2 different answers, so this is going to be the finale. Then, it becomes like 0, 8.0, then 72.6, we got 30.3, we got 3, we got 2, we got 4. Okay, 3.9 minus 58.4, 5, 13. This is not right. Oh shit, I'm confused. 7 and it's alright. Get confused with 13 minus 8. No problem. That's it. 83.9 and 58.4. So it's gonna be 5. And this becomes like 13. So it's 5 and 8. And yeah, it's 5, man. Okay. 80. Oh, the spirit's straightforward. That's like 10. Of course. Yep, so sure. Yeah. Board, make a mistake. 0, 1. 84.3 minus 23.6 plus 13. Like 3. And we have 7. 0. And we have 6. 60.7, is that correct? No. Yes. Okay, cool, it's correct. Then 44.3 minus 28.3. 44.3 minus 28.3, it's 0. 14, then 3, 6, 1. Holy shit. 10. For real? It's not 10. Yo, why is this 0? I said 6, right? 14 minus 8, 6, 16. Yo, this is the last question. I want to fuck it up. 44.3, 28.3, 0, 14, 6, 3 minus 16. Wait, work. Okay. Moving forward. We're at 4.4 minus 3.01. We have 3, 2, 1. No, nothing. Extend 3 then. 8.02 minus 2.42 minus 0 from 10 7 6 5.6 2.52 minus 1.85 square 22 minus 1.5 12 7 14 1 6.67 70s 9.67 1.63 also the 4 and 0 and 8 4 okay. 8.0 minus 7.02 is 1 5.2 minus 4.51 0 is going to dance 11 4 dead 9 12. Oh shit, got 69. 4.85 minus 4.54. 4.85 34. 1 and 7.7. Oh shit, it's correct. Oh no! No, I lost my premise. Yo, why did I say 7? What? Yo, I'm still making a mistake. 6.1. Damn, son. I get like nervous when it comes to the last question. Yo, I don't like that. Uh, 4.6. So 4, 5, 7, 3.75, 9.35 minus 1.6, and 5 is 13, is like 8, 7, 7.75, 5.7 and 3.76. It's 10, it's 16, 4, 4, 16, what is this? 9, and 1, 1.4. Yo, okay, 4. Let's reverse the shit. 4, 10, 17, yo, 5.7. Okay. 2.10 minus 1.0. It's like 10, 8, 0, 0, 1.08. Last question again. I'm panicking. 0. Holy shit, come on. I'm not gonna make a mistake, please. Oh man, sorry. So we have 50.441 minus 6.203. Okay, so it's 11. Then 3. Now we have like, what's this? 8, 9, 10, 11, 4, 3 minus 0. 2, 4, 44.238. 0.595, and then select 10. It's going to borrow from this guy, but then we got borrowed from that guy. 12, and then yeah, it's going to borrow from this guy as well. We have 5, 0, 7. Let's bring down 13, and so yeah, if I add like 0.95 this, then I'm gonna get like 10, and then 9, 10 as well. It says 7, 8, 13, 1, this one 14.3, yeah, 25, 25.246 thousandths, then 1.85, bring down 6, so it's 14, it's 9, so it's almost 11, so it's 4, so 3, and then another 3, and then 2. If I add 1.85 to that, I should go back to the original number. 6, 14, 1, 4, 12, 4, 5, 25, 6. Okay, so our answers are 23.36. My back. My back hurts. 47.3 minus 0.883 is 10. From 9 becomes 12. Becomes 6. So you have 7, 9, 4, 4 to 6. Let's do it. Let's add back 3, 8, 8, 0, 10, 10, 12, 13, 47.3, yeah, 46.417, so 83.9 minus 0.584, like 10, 9, 8, and so we have 6, 1, 3, 8 of 3. We have 83.316. So 5, 8, 4 that. Then, what's this? 9? 83.9. Yeah, cool. So 3.05 minus 0.338, and then 4, 10, 2, and like 2, 1, 7, then like, what's this? Oh shit. 2.712. Let's add that 0.33338, 10, 5, 10, 3, 96.7 minus 0.163, and then 9 and 6, 7, 3, 5, just bring in 96. 96.537, 537, 361, 10, 10, 6, 7, 96.7. Nice. I'm just gonna grab my chocolate drink. And back. Got myself coffee, and then adding subtracting distance. Ah, shit, I hate word problems, but let's go.
On Saturday, William's parents gave birth to twins and named them Nadia and Vanessa. When they were first born, Nadia weighed 7.27 pounds and was 21.5 inches tall, and Vanessa weighed 8.34 pounds. How much did the babies weigh in total? So they tell us Nadia weighed 7.27 and Vanessa weighed 8.34. We have to add those up. And really, they just gave us the length of Nadia at birth really as a distraction, just so that we just don't mindlessly add any numbers we see. So this is really unnecessary information just to distract us. So we need to add Nadia's birth weight plus Vanessa's. So it's 7.27.
15.6
So 7.27 plus 8.34. And it's always important that we line up the decimal. And I'd like to do the decimal first. So it's 8.34. And we'll just add these two up. So 7 plus 4, and this is really 7 hundredths plus 4 hundredths is 11 hundredths, which is the same thing as 1 hundredth and 1 tenth. 1 tenth plus 2 tenths plus 3 tenths is 6 tenths. We've got our decimal sign right over there. And then 7 plus 8 is 15. Or you could even say it's 5 ones and 1 10. And we're done. They weighed 15.61 pounds in total.
Leo has $4,522.08 in his bank account.
Wow,
He deposits another $875.50 and then withdraws $300 in cash. How much is left in his account? So he's starting with $4,522.08. Let's write that down. $4,522.08. And then he deposits or he adds another $875.50. So he's going to add $875.50. When you deposit into an account, you're putting something into the account, or you're adding to the account. So after he adds that $875.50, what does he have? So we go back to the penny spot, or we could view that as the hundredths. A penny is 1/100th of a dollar. 8, let me switch colors. We have 8 plus 0 is 8. 0 plus 5 is 5. Have the decimal right there. 2 plus 5 is 7. 2 plus 7 is 9. 5 plus 8 is 13. Put the 3 down here and regroup the 1, or carry the 1. 1 plus 4 is 5. So after the $875.50 deposit, he has $5,397.58. Then he withdraws. He withdraws $300 in cash, or he takes out $300. So we'll have to subtract that. So then he withdraws 300. Then he withdraws $300. And I just added some trailing zeros after the decimal. $300 is the same thing as $300.00. And then we subtract. And then we can subtract. 8 minus 0 is 8. 5 minus 0 is 5. We have our decimal right there. 7 minus 0 is 7. 9 minus 0 is 9. 3 minus 3 is 0. And then 5 minus nothing here is 5. So he's left with, in his account, $5,097.58.
Hey, quiz. Oh shit, it's quiz time. But we're gonna do the practice first. The base of this grandmother, who takes a train 6.7 kilometers in the car, 1 minute journey. Okay, I'm gonna do it. Okay. 6.37 plus 5.45. So 12. 11.8. To visit her Malek takes a motorcycle in 30.8 meters and course. In total, the journey takes 54 minutes. How many kilometers? What's up with this? It's a distraction. Yo, it's insane. Orla and Eduardo each look at a strand of their hair under microscope measured diameter. Orla's strand was 0.005 diameter, and how much greater was the diameter of Eduardo's hair? Oh, okay, so we're gonna subtract 0.0. Oh, it's gonna be like 7 thousandths, right? Right? Like that? But just to be sure, with 12, 7, 0. Oh shit. Ah, awesome. There's a horse and a mortars. Okay, 4.31, please. Done. We're done. Am I recording or pause? Take the quiz. We're gonna take the quiz. Subtract. You may use the model shown to help find the difference. Yo, this is hard. 8, 9 here. That's the 1. 10. And 1. Oh, that's correct. Please be correct. It does look like it because, like, if you add 0.08, it becomes 1. Oh shit. Oh. Why did I insane. God damn it. It's so hard to trust your instincts. We have 55 minus 2 is 3, and then we have 15 minus 8, 7. Oh, wait, what? What's this? 9? 9 minus 8. So we have 3. According to Jack's pedometer, well, how far did the what? Okay, 2.783 plus 3.124, 2.783, 3.124. So, okay, 7, 10, 8, 9, 5.97. Find the sum. Subtract. God damn it, I made a mistake. Level down. Oh shit, survey not level down. 1.59. 10. 9, nothingness there. 1, 4 to 1. Just to be sure. 0 point plus 4 to 1. Then 6, 4, 10. 4 to 1, please. Several screw on a scale, and the scale reads 80. Okay, then adds one more screw. What is the mass of the last screw? Notice the difference on the unit. Oh shit. Let's do it again. Several screws. The scale reads 80. Okay. What is the mass of the last screw? Definitely the difference. 80.155. Okay, let's see. Okay, so you have 84.81 minus 80. 84.81 minus 80.9. Yep, 10 becomes 10. Minus 0 becomes 10. This becomes like 7. Then 17. 3. Okay. Yep. 5. Yeah. 5. We have 8. 3, none. So it's going to be 3.855. Okay. Then if I add 80.955 back, you get this answer. You get this 4, 10, 11, 9, 18, 4, 84, 84.81, 84 point, that's great. 62.7 minus 34, 7, 12, 8, yep, 2, yep, 28.7, add back 34, 7, we have 12, 2.7, cool, okay, 0.5, it's pretty much sure about this, it's 0.16, please. Now we're multiplying decimals. And then divide the shit into a ton of videos. Okay. I've been recording. Then R. Okay. Let's take multiplying decimals. Let's learn.
Let's see if we can multiply 9 times 0.6. 9 times 0.6. Or another way to write it, we want to calculate 9 times 0.6. I'll write it like this, 0.6. We want to figure out what this is equal to. And I encourage you to pause the video and try to figure it out on your own. And I'll give you a little bit of a hint. 0.6 is the same thing as 6 divided by 10. We know that if we start with 6, which we could write as 6.0, and if you were to divide it by 10, dividing by 10 is equivalent to moving the decimal place one place to the left. So 6 divided by 10 is 0.6. We're moving the decimal one place to the left. So I'm assuming you've given a go at it, but what I'm going to
Is this supposed to be like 5.4?
do is use this that we already know to rewrite what we're trying to multiply. So 9 times 0.6 is the same thing as 9 times 0.6 is 6 divided by 10. And this expression right over here, we could either do the 6 divided by 10 first, in which case we would get 0.6, and this it would turn into this problem, or we could do the 9 times 6 first. And so let's do 9 times 6, which we know how to calculate, and then divide by 10, which we also know how to do. That's all about just moving the decimal place. So we could write 9 times 6. 9 times 6, we already know, is 54. I'll do that in orange, is going to be 54. So this right over here is 54. And now, to get to this expression, we have to divide by 10. We have to divide by 10. And what happens when we divide something by 10? And we've seen this in previous videos, why this is the case. This is all about what decimal notation means. Each place is 10 to the place, it represents 10 times as much as the place to its right, or each place represents 1/10 of the place to the left. So 54 divided by 10, this is going to be, you could start with 54, and I'll put a 0 here after the decimal, and when you divide by 10, that's equivalent of shifting the decimal 1 to the left. This is going to be equal to 5.4. And that should make sense to you. 5 times 10 is 50. 0.4 times 10 is 4. So it makes sense that 54 divided by 10, I shouldn't say equal, I'd write 54 divided by 10 is equal to 5.4. So this right over here is equal to 5.4, and that's what this is. This is equal to 5.4. Notice, 9 times 6 is 54. 9 times 0.6 is 5.4. Now you might see a little pattern here. Between these two numbers, I had exactly one number to the right of the decimal. When I take its product, let's say I ignored the decimal. I just said 9 times 6, I would have gotten 54. But then I had to divide by 10 in order to take account of the decimal, take account of the fact that this wasn't a 6, this was a 6/10. And so I have one number to the right of the decimal here. And I want you to think about whether that's a general principle. Can we just count the total numbers of digits to the right of the decimals, and then our product is going to have the same number of digits to the right of the decimal? I'll let you think about that.
Wow. Yeah, it should be.
So right over here, we want to compute what 3 times 0.25 or 3 times 25 hundredths is. And so I encourage you to pause the video and see if you can figure this out.
Okay,
All right, now let's work through this together. And in this video, we're going to explore multiple strategies. In the future, we're going to show you what's called the standard strategy, which you might use a lot. But the strategies we're going to look at in this video are actually very helpful for understanding what multiplying decimals actually means, how it relates to multiplying fractions, and it's often the way that people, even people who have a lot of math behind them, how they actually multiply decimals. So here, 3 times 25 hundredths. So there's a couple of ways to think about it. One way is to say, hey, this is the same thing as 3 times, and I'm just going to write it a different way, 25 hundredths. Hundredths. So if I have 3 times 25 of something, what is it going to be?
75.
Well, what's 3 times 25? Let's see. 2 times 25 is 50. 3 times 25 is 75. So it's going to be 75. And I'm multiplying not just 3 times 25, I'm multiplying 3 times 25 hundredths. So instead of 25 hundredths, I'm going to have 75 hundredths. So written out in words, this would be 75 hundredths. Now how would we write that as a decimal? Well, that is the same thing as this, 75 hundredths. Now another way to conceptualize this, to think about what this is if we were to write 3 times, we could write it as a fraction. We could write 25 over 100. This is another way of writing 25 hundredths. These are all equivalent. So what is 3 times 25 over 100? Well, same idea. This is going to be equal to, you could say this is 25 over 100 plus 25 over 100 plus 25 over 100. This is going to be 75 hundredths, which once again is 0.75. If you wanted to more formally view it as fraction multiplication, you could view it as 3 over 1 times 25 over 100. And you multiply the numerators, you get 75. You multiply the denominators, you get 100. Either way, in all of these situations, you're going to get 75 hundredths. Or another way to think about it is, hey, look, this thing right over here, this 25 over 100, this is the same thing as 1/4. So you could view this as 3 times 1/4. In fact, this is a decimal that it's good to recognize that this is the same thing as 1/4. So you could view this as 3 times 1/4, or 3/4. This is a fourth right here. 1/4 could be viewed as a fourth. So this is going to be equal to 3/4. 3 over 4. 3/4. All of these are equivalent. Now, if someone wanted it written out as a decimal, you might know that 3/4 can be expressed as 75 hundredths, which in general is a good thing to know. Now let's tackle slightly more complicated examples. So let's say we wanted to figure out what 0.4 times 0, let me just in a new color, times 0.3 is going to be equal to. Pause the video and see if you can compute this. And I'll give you a hint. See if you can express these as fractions. All right. So what we have here in white, we could read this as 4 tenths. 4 tenths. And we could write it as a fraction as 4 over 10. And we're going to multiply that by what we have over here. This is 3 tenths. 3 tenths, which we could write as a fraction as 3 tenths. And so you could view this as 4 tenths of 3 tenths, or 3 tenths of 4 tenths, but we're multiplying these fractions, which we've seen before in other videos. And so what's going to happen? Well, if we multiply the numerator, we get 12. Or the numerators, we multiply the denominators, you get 100. So you get 12 hundredths. So if you wanted to write that as a decimal, it would be 0.12. 12 hundredths. Now you might notice something interesting here, and you'll see this more and more as you learn the standard method. Well, 12 is 4 times 3 is 12. But now I have 2 digits behind the decimal. But notice I have 1 digit behind the decimal here, 1 digit behind the decimal here, for a total of 2 digits behind the decimal. So I'm giving you a little bit of a hint about where we're going, but the important thing for this video is to recognize that you can re-express each of these as fractions, and then multiply the fractions to get something expressed in terms of hundredths, and then express that as a decimal. Let's see if we can calculate 2.91 times 3.2. And I encourage you to pause this video and try it out on your own. So the way I'm going to think about it is 2.91 is the same thing as 291 divided by 10. And we know that when you, or not divided by 10, divided by 100. And we know that if you divide something by 100, you're going to move the decimal place 2 places to the left. 1, 2, and you would end up at 2.91. It also makes sense. If I take 2 and I multiply it by 100, I'd get 200. Or if I take 200 and divide it by 100, I would get 2. So it makes sense that 2.91 is the same thing as 291 divided by 100. Similarly, I can never say that word, 3.2 can be rewritten. It's the same thing as 32 divided by 10. Now, why is all of this interesting? Well, I could rewrite 2.91 times 3.2. I can rewrite 2.91 times 3.2 as being the same thing as, instead of 2.91, I can write 291 divided by 100. 291 divided by 100. And then times, instead of writing 3.2, I could write 32 divided by 10. And this can be rewritten as, this is going to be equal to 291 times 32 divided by 100, I'm just reordering this, divided by 100 divided by 10, divided by 10. Or I could rewrite this as, this is equal to 291 times 32. If I divide by 100 and then I divide by 10 again, I'm essentially dividing by 1,000. So this part right over here, I could rewrite as dividing by 1,000. Now, why is this interesting? Well, I already know how to multiply 291 times 32, and then we know how to move the decimal so that when we divide by 1,000. So let's calculate 291 times 32. Let me write it right over here. 291 times 32. Notice this, I've just essentially rewritten this without the decimals. So this right over here, but of course these are different quantities than this one is right over here. To go from this product to this product, I have to divide by 1,000. But let's just think about this. We already know how to compute this type of thing. 2 times 1 is 2. 2 times 9 is 18. Carry the 1. 2 times 2 is 4 plus 1 is 5. And now we can think about the 3. 3 times 1, all right, actually, let me throw a 0 here because this isn't a 3, this is now a 30s. This is in the tens place, so that's why I put a 0 there. So 30 times 1 is 30. That's why we say 3 times 1 is 3, but notice it's in the tens place right now. And then 3 times 9 is 27. Carry the 2. 3 times 2 is 6, plus 2 is 8. And now we can add. We can add, and we would get 2. 8 plus 3 is 11. 6 plus 3 is 13. And then you get 9. So you get 9,312. So this is going to be equal to 9,312 divided by 1,000. Divided by 1,000. And what's this going to be equal to? Well, if we start with 9,312, and let me throw a decimal there, dividing by 1,000 is equivalent to moving the decimal over 3 places to the left. So you divide by 10, divide by 100, divide by 1,000. So that's going to be 9.312. So if you divide by 1,000, you will get to 9.312. Write this 9.3. Let me write the decimal in purple. 9.312. Now, there's something very interesting here. In our original, when we wrote the expression, we had 1, 2, 3 total numbers behind the decimal. And then over here, we have 1, 2, 3 total numbers to the right of the decimal. Why is this? Well, let's think about it. We re-expressed this. We re-expressed this as 291 divided by 100. And this is 32 divided by 10. The 100 dividing by 100 and dividing by 10, this essentially accounts for these 3 decimal places. So we essentially get rid of those 3 decimal places, but then we have to reintroduce those 3 decimal places by dividing, or we have to shift. Here we shifted the decimal in aggregate to the right 3 times. 1, 2, and then 3. Now, in order to make sure we get the right product, we got to shift it back to the left. So we're shifting it 1, 2, 3. So when we went from this to this, for the whole product, it was like multiplying. It was like dividing by. We essentially to go from here to here, we multiplied by 100. To go from here to here, we multiplied by 10. So in aggregate, we multiplied by 1,000. If you think about both of these. And so now we have to divide by 1,000 to get the right value. So that's why 3 decimal places to the 3 numbers to 3 spaces to the right of the decimal here, 3 digits to the right of the decimal here.
Makes sense.
Let's multiply 1.21, or 1 and 21 hundredths, times 43 thousandths, or 0.043. And I encourage you to pause this video and try it on your own. So let's just think about a very similar problem, but one where essentially we don't write the decimals. Let's just think about multiplying 121 times 43, which we know how to do. So let's just think about this problem first as kind of a simplification. And then we'll think about how to get from this product to this product. So we can start with, so we're going to say 3 times 1 is 3, 3 times 2 is 6, 3 times 1 is 3, 3 times 121 is 363.
Okay, let's stick to my answer.
And now we're going to go to the tens place. So this is a 40 right over here. So since we're in the tens place, let's put a 0 there. 40 times 1 is 40. 40 times 20 is 800. 40 times 100 is 4,000. And we've already known how to do this in the past. And now we can just add all of this together. And we get, what do we call it here? 3 plus 0 is 3. 6 plus 4 is 10. 1 plus 3 plus 8 is 12. 1 plus 4 is 5. So 121 times 43 is 5,203. Now, how is this useful for figuring out this product? Well, to go from 1.21 to 121, we're essentially multiplying by 100. Right? We're moving the decimal 2 places over to the right. And to go from 0.043 to 43, what are we doing? We're removing the decimal, so we're multiplying by 10, 100, 1,000. We're multiplying by 1,000. So to go from this product to this product, or to this product, we essentially multiplied by 100 and we multiplied by 1,000. So then to go back to this product, we have to divide. We should divide by 100. We should divide by 100 and then divide by 1,000, which is equivalent to dividing by 100,000. But let's do that. So let's rewrite this number here. So 5,203. Actually, let me write it like this, just so it's a little bit more aligned. 5,203. And we can imagine a decimal point right over here. If we divide by 100, see, divide by 10, divide by 100, and then we want to divide by another 1,000. So divide by 10, divide by 100, divide by 1,000. So our decimal point is going to go right over there. And we're done. 1.21 times 0.043 is 0.05203. So one way you could think about it is just multiply these two numbers as if there were no decimals there. Then you could count how many digits are to the right of the decimal. And you see that there are 1, 2, 3, 4, 5 digits to the right of the decimal. And so in your product, you should have 1, 2, 3, 4, 5 digits, 5 digits to the right of the decimal. Why is that the case? Well, when you ignored the decimals, when you just pretended that this was 121 times 43, you essentially multiplied this times 100,000 by 100 and 1,000. And so to get from the product you get without the decimals to the one that you need with the decimals, you have to then divide by 100,000 again. Multiply by 100,000 is essentially equivalent to moving the decimal place 5 places to the right. And then dividing by 100,000 is equivalent to moving the decimal 5 digits to the left. So divide by 10, divide by 100, divide by 1,000, divide by 10,000, divide by 100,000. Either way, we are done. This is what we get.
In this article, you'll learn how to multiply distance with jumping and giving it a region with first. The problems go from easier to more difficult. Don't do their examples and explain the it's not. If you're not confused, just think of it as a chance to learn. Let's start by multiplying two events. Okay, I guess this is the answer. 16. Okay, beautiful. Let's move on to multiplying whole numbers by tens and hundreds. Oh, okay, that's hard. It's 5.6. Oh shit, crap. 1.5? Oh no. Yo, 105. Okay, this was pretty hard. Let's see. 5 times 5 is 25. 5 times 7 is 35 plus 35 plus 40. Then like the rest is like this, 4.0. Holy shit, is that right? Oh, no, not at all. Let's see. 5 times 5 is 95. Yep. It's really good. Oh, I feel too. Why did I say? Oh, it's so weird to say that. And then 5 times 7 is like 35. This is like 37. 3.75. It's like there's 2 of them, so I'm just going to be careful with that. 0.43. 12, 8, 16, 17. Great, let's finish with a few more challenging problems. Okay, 0.462. Okay, 62 times 4. Okay, 4 times 6. What's 4 times 6? We have 24 plus 8. Yo, should be like that and then this. Actually not. So, there we go. 717. Let's just write it down. 77. 7, 49. 4, 49, 53. Then like the rest of the same 5. Okay. 1.2 times 7. We have 14, 7, 8, 14. 1, 7, 8, 4, 12, 1, 9, then 2 of them, 19.4. I don't know, pretty wrong. Yeah, I know it's wrong. Why did 12 times 77, let's try again. 14, 7 is 1, 8, and 14 again. 14, then 7 is 1, 8, and then we got 4. Well, 9.24. Why did it say 19? Oh, it's insane. Can't even make sense. It's 19. 7.7. Lol. 4. 4. 12. 3. 9. 4. 5. 10. Like 2 of them. 10.4 piece. 4. 4. Okay. Then we're. Oh shit. Talk videos. This figure's not scale. What makes me the area model above per percent? Okay, it's 2.7 times 4, 5. Yeah? Okay. Which large square is 1 whole? Which multiplication represents the figure? Holy shit. What is this? Yo, okay. I'm pretty sure it's 2.40. Holy shit, there's 2 of them. Oh, this one makes much more sense. Okay, let's figure it's 9 times 9 thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the 9 things. So each of these is like what, 7 I guess? From 7 to 7, 9. Cool. The figure's natural scale, which is 3.8 times 260. Right? 3.8 times 260. Just 1. The entire figure. Which would be actually calculation that represents the figure. 5 is 0.2. Okay, so I solve that. You like 10, and then we have 2. 0.1. Okay, I have 0.1. Okay. Yo, okay, wait a sec. Oh, cool. Awesome. Start multiplying, understanding functions. Match each expression to its product. Oh my god. I guess it's the places, right? 3, and then 1, and you have 2 of those. Two 27949. It's gonna be like the same shit, and then like move 2 places. So 517. Okay. It's 1, 1, 2, 3, 1, 3, 1. Sophie knows that 9. This is understanding of Sophie's solve 9.1 6. So it's like 3. So 23, 49. Okay, cool. Okay, cool. Next. Multiply all numbers at 0.1 Oh shit, it's hard. Yo, 0.44. Oh my gosh, it's hard. Point, like, this is 83, right? Cool. Okay, multiply decimals and whole numbers visually. Oh my god, what's this? Using number line can imagine moving 0.4 times. Yo, what's this? 12? Right? Yeah. You may use the models shown below to find the product. I'm pretty sure this point is 84. But I don't know. Okay, cool. What expression can represent the following number line? Okay. Choose one answer. So this is like 0.15 times 2 jumps, and then each of those jumps are 0.15. Which model can be used to represent 0.7 times 3? Okay, this one's reasonable. 0.7, here it goes. Just one answer. No, this one's not. Here's another. Sure, you're wrong. I think we're wrong, but maybe this. Dude, I'm not sure. But which number line can we use to represent 5 times 0.5? Okay, it's like 2.5, right? So this means 2.5. Okay, cool. Let's multiply all numbers and decimals. Multiply. We're gonna multiply. 7,000 Oh shit, I'm gonna do it here. 7, 6, 13 times 4. 7, 1, 6, 1, 3 times 4, we have 12. 4, 5, and 4, and 8, 30, and then we're gonna 4. Okay. 19 times 8 is 5. Let's get 45, 4, 5, 9. 0, 8 times 9 is 7. 2, 15. Yeah, then 5, 11, 6, 1, places. Please. Okay, 24 minus 8. Okay, it's going to be 40. 0, 4. That's going to be like 32, 16, 19. Then this one is 194. Okay, cool. 5 minus 3, 6, 17, 17, 70.76. Oh shit, so much. Okay. Dude. Yo, it's 1.2. Okay. What? I wrote 7.5, dude. Okay. Man, so sad, man. Yo, what's this? 4, right? Try again. Standard algorithm. What's this mean? Oh shit. Oh, 56, 60. Yeah, 60. Wait, what? Is it 60? Yo, 6. 5. 30. 18. 1. 2, 1. Yo, what? Yo, once? It's not right. 30, right? 6, 12. 12 is just 15. Oh my god. Yo, am I right? Let's restart typing 4. And this one's already just right. 0.4.8. Sick. Uh, 0.8, please. Right? Oh, this one's gonna be 4. Times 4 is 1, so I'm going to 5. That's 1.5 instead. Yo. Yo, what's this? 7? 1.4? Standard algorithm. Let's do it. 1, 3, 9. We have 18, 6, 7, 2, and 56. 147 times 9. What's this? 63, 63. And then like 36, 42, 9, 13. Then we can have here 1, 2, 12, 14, 3, 4, 3, 3, 7, 5. And you have like 3 decimals, so 5.7. Let's get the rectangle. Okay. 147, 9, 4, 28, 32, 3, 7, 10. 10.21. Yo. Okay, cool. 796 times 68. Let's make this neater. 796 times 68. It's gonna be, what's this? 848, 72, 76, 6, 6 plus 7, 63, right? I don't know. 6 times 6, and there's 6. And 6 times 9 is 54, is 7. 42, 47. You have 8, 12, 1, 11, 6, 7, 14, 4 plus 1, 5. And then like here, that's like 54.14. Yo, is this incorrect? Let's do it again. Let's do it again. 796 times 68. 48. 4. 9 times 8, 72. 7, 7, 4, 7, 6. 7 times 8 is 56. 56 plus 7 is 63. 36, 6, 3, 54, right? Yeah, 54, 7, 5, 7 times 6, 42, 47, add all the shit up. 12, 4, 11, 7, 7, 14, 54, 1 to 8, and then the decimals 3 spots, and 3 spots, okay. 2, 145, 36, 2, 4, 5, 36, 30, 4, 4, 7, 12, 14, 15, 13, 6, 7, 0, 12, 8, and 8, 88. That's 8. Oh, actually, you know what the heck? We have 8 different places, right? 8.8. 18, 8, 9, 18.98. 67 times 5, 35, 30. Yo, is this right? Oh, it's the last question. I don't know. 35, 35, 30, 33. Standard conflict. There's 2 more. Okay. 106 times 200. 54. 5. 9. We have here 12. 2. 1. 2 again. We have here 12. Oh shit. Uh, 12, 1, 2, 0, 2 again. 4, 7, 10, 12, 3, 2. Then like here's 4 decimal places. 2.3274, please. 2, 3, 2, 7, 3, 4. Oh. 106. Where did I go wrong? 9 times 6 is 4, right? 4. 9 times 5 is 45. 6 is 4. 7, 6 is 3. 0, 5. 9, 12. 1, 2. And the same shit. 1, 2. Add those with 4, 7, 10, 12. 4 and oh shit! Oh shit! shit. Yep. 10, 35, 36, 10, 18, 8, 8, 10, 10, 3 decimal places, and 8, 50, 500, 508, 3 times 89, 7, 2, 72, 74, 7, 45, 52, 4, 64, 66, 46, 7, 8, 8, 11, 5, 1, 8, 8, and 7. Okay, it's a lot of numbers. $162. I guess it doesn't matter, does it? I don't know. Let's figure it out. 14, 4, 12, 13, 9, 18, 19, 0, 2, 4, 30, 36 was 4 is 40, 9 times 6, 54, 58, then 7, 6, 9, 4, 5, 16, 10, 16, 15. Oh shit, what's this? What's this number? 16. 6, 6, 4, 1, 2, 3. Let's try again. 6, 2, 3 times 51. 3, 2, 6, and 5 times 15, 10. Fortunately, right. 11, 30. Oh, it's a lot. 51. Ah, shit. No, why? God damn it. 1, 2, 7, 9, 14, 0, 7, 2, 9, 11, 15, 19, 3, 1, 2, 1, 16, 4, 5, 9, 11, 4, 4, 1, 6, 1, 4, 4, 1, 9, 6, 1, and then 4 decimal 5 actually. 58, 16, 9, 10. Oh, it's a shame shit, I made a mistake. No, actually not. 5. 10, 5, 6, 5, we have 6, 9, 12, 11, 4, 1, 2, 9, 6, and then places. Yo, some big number. 3, 4, 20, 0, 2, 36, 15, 1, 27, 10, 2, 1, 18, 0, 7, 7, 8, 11. It's whoa. 1, 2, 3, 4, 5, 6. Shy. It's insane. 8, 3, 6 times 8, 8, 3, 6, 8, 5, 5, 30, 15, 18, 41, so 30, 30, right? Yeah, 30, 15, 18, 41. Yo, same shit. Of course. And then like 8 times 6, 48. 8 times 4, 24 plus 8, 28. 8 times 8, 64. 64, 66. Okay, like 0, 0. No, not 0. 8, 16, 17, 14, 11, 7. 7, 1, 4, 7, 80. Then 12 house. And we do the whole thing just to be sure. 836, 855, 30, 18, 41, and the same thing. 1, 4, 4, 180, 4, 180, 48, 4, 8 times 3 is 24 plus 8 is 28, 24 plus 4 is 28, 2, 64 plus 2 is 66, you have 0, 8, 16, 17, 10, 14, 10, 11, 7, and then like you have two decimal places. You have 7,147.8. Cool. Large number. 568 times 71 would be 8, 6, 5, 56, 42, 47, 30, 35 to 39. We add, we have 8, 12, 13, and 4. This one is 408. Of course, do it again. 8, 6, 5, 6, 42, 47. What's this? 35, 39. 8, 12, 13, 10, 403.28. 2, 7, 6. Oh, it's not 7. 4, 14, 4, 5. Wait, right? Is it right? 4, 14, comes to 4, 5, 7, 14, 49, 50. Okay, 14, 19. Same shit, I guess. 0, 4, 0, 19. Oh shit, it's a lot. Let's see if that's correct. No, it's 0. 4091. 4, 8, 9, 9, 10. 2, 9, 9. 4 and 4 decimal places. 1, 4. That's not the wrong. Oh, shit. Fourteen, 15, 14, 49, 50. 49, 4. Yo, I got a different answer this time. Yo, it's pretty sick. Two oh nine nine. Got it 4. Oh no. Is it 8 4 or 7 4? 772 times 270. 772 27. 4 14. 14 15. 14. 49 50. 49 54. We have 4. 14. Yep, 14, right? Yep, 14. This one 15. 4, 8, 9. 9. Then 209. 984. 209. 984. 1, 2, 3, 4. 209. That's a lot. 902. 9, 0. 9, 9, 2. 99. No. 902. 902. 992. 2229. Yo. Worse. 6. Okay. 6,903. 6903. 37. 21, 2, 71. Yeah, 21. Then 0 to 63. Then 6 times 7, 42, 48. Then we have 9, 0, 7, 18, 1, 11, 4, 15, 5, 2, 5, 5, 4, 1, 1. Sure, that is right, man. 230 times 56. 2, 3, 2, 5, 6. Oh, you have 12, 18, 19, 12, 13, 10, 3, 15, 16, 10, this one, 11, you have 2, 2, 9, 9, 1, 2, 9, 9, 1, 2, 3, dot, go. Times 5, 40, 35, 39, 20, 23, 10, 12. Okay, 1, 19, and then the decimal places up 4 times 1, 2, 3, 4. Okay, 8,124, 8, 1, 2, 4 times 71. We're going to have 4, 2, 1, 8, 0, 4, 8, 14, 16, 7, 8, 56, 4, 10, 7, 8, 16, 7, 5, 57.68, therefore, decimal should be at third place. So we got it. Now, 6.1. Great. Wow, this was insane. Insane, dude, insane. Oh my god, it's a lot of videos.
Let's take 63 and divide it by 35. So the first thing that we might say is, okay, well, 35 doesn't go into 6. It does go into 63. It goes into 63 one time, because 2 times 35 is 70, so that's too big. So it goes one time. So let me write that. It goes one time. 1 times 35 is 35. And then if we were to subtract, and we can regroup up here, we can take a 10 from the 60, so it becomes a 50. Give that 10 to the 3, so it becomes a 13. 13 minus 5 is 8. 5 minus 3 is 2. So you could just say, hey, 63 divided by 35. Let me write this. You could say 63 divided by 35 is equal to 1 remainder 28. 1 remainder 28. But this isn't so satisfying. We know that the real answer is going to be 1 point something something something. So what I want to do is keep dividing. I want to divide this thing completely and see what type of a decimal I actually get. And to do that, I essentially have to add a decimal here and then just keep bringing down decimal places to the right of the decimal. So 63 is the exact same thing as 63.0, and I could add as many zeros as I might want to add here. So what we could do is we just make sure that this decimal is right over there. Is we can now bring down a 0 from the tens place right over here, and you bring down that 0. And now we ask ourselves, how many times does 35 go into 280? And as always, this is a bit of an art when you're dividing a 2-digit number into a 3-digit number. So let's see, it's definitely going to be, let's see, if I were to say, so 40 goes into 280 7 times, 30 goes into 280 about, well, it goes about 9 times. So it's going to be between 7 and 9. So let's try 8. So let's see what 35 times 8 is. 35 times 8. 5 times 8 is 40. 3 times 8 is 24, plus 4 is 28. So it actually works out perfectly. So 35 goes into 2 times 35 times 8 is. Between 7 and 9, so it goes into 280. So 40 goes into 280 7 times. 30 goes into 280 about, well, it goes about 9 times. So it's going to be between 7 and 9. So let's try 8. So let's see what 35 times 8 is. 35 times 8. 5 times 8 is 40. 3 times 8 is 24, plus 4 is 28. So it actually works out perfectly. So 35 goes into 280 exactly 8 times. 8 times 5, we already figured it out. 8 times 35 is exactly 280, and we don't have any remainder now. So we don't have to bring down any more of these zeros. So now we know exactly that 63 divided by 35 is equal to exactly 1.8. In this video, we're going to come up with some strategies for division when the quotient isn't a whole number, when it's going to be a decimal. So let's try to compute 3 divided by 2. Pause the video and see if you can figure out what that is going to be. And I'll give you a hint, it's not going to be a whole number. Alright, now let's try to work this together. And like all things in mathematics, there's multiple strategies that you can use to try to figure out what 3 divided by 2 is. One strategy is, well, let's just rewrite this as a fraction. So 3 divided by 2, you could write that as 3 over 2. Now, or you could say this is the same thing as 3 halves. But how can we express this as a decimal? Well, you might recognize that 3 halves is the same thing as 2 halves plus 1 half. Let me write that down. So this is the same thing as 2 plus 1 over 2. And I'm really doing every step here to hopefully make things clearer. Which is the same thing as 2 over 2. So that's 2 over 2 plus 1 over 2 plus 1 half. I could break this up into 2 over 2 plus 1 half. Now 2 over 2 is just 1. And so this is going to be equal to 1 and 1 half. Now you might immediately say, hey, a half, I could write that as 5/10, and that would be exactly right. You could just, if we want to spell out every step, we could say this is equal to 1. And since when we write it in decimal form, we express things as tenths or hundredths or thousandths. So 1 half is the same thing as 5/10. And if we wanted to express that as a decimal, this would be equal to 1 and 5/10. 1 and 5/10. Now I did every step here. As you get more practice, you say, okay, this is the same thing as 3 halves. 3 halves, 2 goes into 3 one time, and there's a half left over. So writing this as a mixed number, it's 1 1/2. And a half, written as a decimal, is 5/10. So this is 1 and 5/10. Now another way that we could have thought about this is, okay, I'm not getting a whole number when I divide 3 divided by 2. Maybe I'll get something in terms of tenths. So let me express each of these in terms of tenths. So 3 is how many tenths? Well, 3 is 30 tenths. 30 tenths. And we'd be dividing by 2. We're going to be dividing it by 2. So 30 tenths divided by 2, well, that's going to be equal to 15 tenths. This is equal to 15 tenths, which is equal to 10 tenths and 5/10, or 1 and 5/10. So both of these are equally legitimate strategies, and 5/10. So both of these are equally legitimate strategies for figuring out what 3 divided by 2 is. I like the first one a little bit. It leverages what we know about fractions. But let's do another example. Let's do a few more examples. This is fun. All right. Let's figure out what 34 divided by 4 is. Divided by 4. And like before, pause this video and try to figure it out and try to see
Bullshit.
if you can use some of the strategies that we used in the last video. Alright, so as we just said, we could re-express this as a fraction. This is the same thing as 34 divided by 4. 34 divided by 4. Or 34 fourths. Now what is this going to be equal to? Well, 4 goes into 34 8 times. So it's going to go 8 times. And you're going to have 2 left over. So this is 8 and 2 fourths. 8. Actually, let me write it. Well, all right. 8 and 2 fourths. Do that 2 in that blue just for fun. 8 and
2 fourths. Usually if it's 1/2, usually it's 5 tenths.
over 4.
Just same as 0.5.
8 and 2 fourths. So how do I do this again? I said 4 goes into 34 8 times. And then I have 2 left over, so I'm going to have 2 fourths left over. Another way, if you want to see all the steps, you could say, hey, I could rewrite this as 32 over 4 plus 2 over 4. The 32 over 4 is our 8, so 8 and 2 fourths. Well, 2 fourths, that's the same thing as 1/2. That's the same thing as 1/2. And if we want to express that in terms of tenths, this is equal to 8 and 1/2 is the same thing as 5 tenths. 8 and 5 tenths, which if we want to express it as a decimal is of course 8 and 5 tenths, or 8.5. And we are done. Let's do another one of these. And actually let's do one of them where we are dividing into a decimal, where a decimal itself is being divided. So let's say we wanted to calculate 8.4 divided by 7. Pause this video and see if you can figure it out. So when you look at this, you might immediately say, well, okay, I know 84 is divisible by 7. We know, if you know your 7 times tables, we know that 7 times 12 is equal to 84, or that 84 divided by 7 is equal to 12. But this isn't 84, this is 8.4. So how do we think about it? Well, one way is we could think about it in terms of tenths. 8.4 is the same thing as 84 tenths. And so 84 tenths divided by 7. Well, 84 of anything divided by 7 is going to be 12 of that thing. So it's going to be 12 tenths. And 12 tenths we can rewrite as 1 and 2 tenths, or 1.2. 1.2. And we are done. So this is equal to 1.2. Another way that we could have thought about this is we could have said, you know what, 84 tenths is the same thing as 84 over 10. In fact, you would read this as 84 tenths. And now you want to divide this by 7. So you want to divide this by 7. This is the same thing. When you divide by something, it's the same as multiplying by the reciprocal. So it's 84 over 10 times 1/7 times 1/7, which is equal to, we can change, well, let me write it this way. This is equal to 84 over 10 times 7, over 10 times 7. And now we could simplify this. If we divide the numerator and the denominator by 7, 84 divided by 7 is 12. 7 divided by 7 is 1. 12 divided by 10, this is going to be equal to 12 tenths, which is 1.2. We could write this as 1 and 2 tenths, or 1.2. Let's do one more example that's kind of related. Let's say we want to figure out what 7 divided by 70 is. Pause this video and try to figure it out. Well, we can rewrite this, as we've been doing, as 7 over 70. Instead of writing it as 70, let me write that as 7 times 10. And what's valuable about this is we can divide the numerator and the denominator by 7. If we divide the numerator by 7, we get a 1. We divide the denominator by 7, we get a 1. Remember, we can do the same thing to the numerator and denominator. If we multiply or divide by the same value, we're not changing the value of the actual fraction. And so you're left with 1/10, which if you express it as a decimal, you go to the tenths place, you say, hey, I have one of those tenths. That's 1/10. So this is 1/10. Another way to think about it is, this is the same thing as, and really this is what we wrote over here, but you could write this as 7 divided by 7 divided by the blue 7, and then you divide by 10. If you're dividing by 7 times 10, we're dividing, actually, let me write that down. If you're dividing by 7 times 10, and this is essentially another way of writing what we have over here, this is going to be equal to 7 divided by 7 divided by 10. Divided by 10. Well, 7 divided by 7 is 1, so you get 1 divided by 10, which is 1/10, 1/10. So you get 1 divided by 10. By 10. We've already learned that when we multiply by 10, let's say we took the number 53, and we were to multiply it by 10, it has the effect of shifting all the digits one place to the left. So this should be a review for you, but this was going to be 530. And we could see that what used to be in the tens place has been shifted to the left to the hundreds place. And what used to be in the ones place has been shifted to the left to the tens place now. And we saw if you divide by 10, you have the opposite effect. And so let's say if I had 120, I could say that let's divide by 10. I could also say this is the same thing as 120 times 1/10. What is going to happen there? Well, in this situation, all the digits are going to shift one place to the right. So what used to be in the tens place will now be in the ones place. What used to be in the hundreds place will now be in the tens place. So this is just going to be equal to 12. So that was all review, but now we're going to extend this a little bit by thinking about things that have place values representing less than a 1, I guess you could say, or we're going to deal with decimals. So just to get ourselves warmed up, let's see if we can figure out what 3.015 times 10 is. Pause this video and see if you can figure that out. Well, the exact same thing is going to happen. All of our digits are going to shift one place to the left. So right now we have a 3 in the ones place. We have a 0 in the tenths place. We have a 1 in the hundredths place. And we have a 5 in the thousandths place. But now they're all going to shift one place to the left. So the 3 is now going to go into the tens place. It's going to shift one place to the left. So we're going to have in the tens place, we're now going to have our 3. And now this 0, which was in the tenths place, is now going to shift into the ones place. So the 0 is going to go right over. The 0 is going to go right over there. That is now in the ones place. And then we'll put our decimal. And now what's going to go into the tenths place and the hundredths place? And actually, I'll rewrite the thousandths place as well. This 1 is going to shift one place to the left into the tenths place. So into the tenths place. And then the 5 that was in the thousandths place is now going to shift one place to the left into the hundredths place. So into the hundredths place just like that. Now we could put a trailing 0 over here, but that's not going to change the value of this number, so I'll just leave it like that. And so there you have it. We see that every digit has shifted one place to the left. So this is equal to 30.15. I'll just put that 0 there for kicks. And so we could think about the other way around. What if I were to take 67.5, and if I were to divide it by 10, or another way of thinking about it is, if I were to multiply this by 1/10. Pause the video and see if you can figure out what that's going to be.
So this is 1.
Well, now every digit is going to shift one place to the right. So the 6 is going to be in the ones place. The 7 is going to go into the tenths place. And then the 5 is going to go into the hundredths place. So let's write that out. So our 6 is going to go into the ones place, and then we're going to have our decimal point. Our 7 is going to go into the tenths place, and then our 5 is going to go into the hundredths place. So there you have it. We get 6.75.
This are really wrong by jumping and giving. The wrong one is a little bit early. Kaya come to stay in this system. Tapos sabi naman, yo, okay. Oh shit, I don't know. 5 divided by 4. 1. 1. Okay. Yo, 6. What's this? 2. And like 6, 8, 19, 125. Uh, 5 goes to 11 like 2 times, then we have 1 over 5. 1 over 5. Oh, it's decimal, man. I can do that. Let's go 2 times. 2 times, and then we have kind of like 2 over 6, 3 over 6. I'm supposed to express this by tens. No. 6, 2, 12, 3, 13, then 12, 13, 15. This 4 with 7 times is like, no, 6 times. 4, 3, 0, we have like 7, 8, 20, we have 5, 6, 5, please. And then 5, 9, 45, 40, and then back to 8, 6. Oh shit. It goes with it's 8 and 48. We have 3. Okay. Shit. 2.5. It's gonna have 5, right? But then gonna be shift. Oh shit, same concept. Like 84, and it's gonna be like 12, but it could be 1.3. 6, it's gonna be 0.08. 9 divided by 30. 3 times. That's 3. 7.8 divided by 60. So, 18, 18, 13. We have 8, 40, 4, 160, 80, 0.4. Even bigger numbers. Oh shit, this is okay. 40, 10, 100, 2, 80, 20, 200. Yo, what the heck? Let's leave these two things. 4, 7 minus 2. And you have like 3 divided by 100. What? 8? 4? Yo, that's insane. That's 9. Oh, it's just double the shit. Okay. Oh, perhaps all videos.
In a previous video, we started thinking about strategies for dividing numbers where either the numbers are decimals or their quotients are going to be decimals. So now let's continue that, and we're going to do a slightly more involved example. Strategies for dividing numbers where either the numbers are decimals or their quotients are going to be decimals. So now let's continue that, and we're going to do slightly more involved examples. So let's say we want to figure out what 500 divided by 200 is. Divided by 200. Pause this video and see if you can figure that out. Well, one strategy for doing this is to just re-express this as a fraction and see if you can simplify this fraction in a way that it's straightforward to express it as a decimal. So for example, this is going to be the same thing. This is equal to 500 over 200. And now we can simplify this. We could say this is the same thing as 5 times 100. 5 times 100 over 2 times 100. The reason why that is useful is you say, hey, look, I have 100 in the numerator, I have 100 in the denominator. 100 divided by 100 is just going to be 1. So you could just view this. This is equal to 5 halves. 5 halves times 100 over 100 times 100 over 100, which is just going to be equal to which is just going to be equal to 1. Another way to think about it, you could divide the numerator by 100, and you would have 5. And as long as you divide the denominator by the same thing, you're not changing the value of the fraction. So if you divide the denominator by 100, you're going to get 2. So any way you think about it, this could be simplified as 5 halves. But we're not done yet. That is what 500 divided by 200 is. But can we express this as a decimal? Well, we can rewrite 5 halves as a mixed number. So 5 halves is going to be equal to, well, how many times does 2 go into 5?
2 times.
Well, it goes 2 times, and then you have 1 half left over. So this is going to be 2 and 1, 2 and 1 half. And now how do we express this right over here as a decimal? Well, you might recognize that 1 half is the same thing as 5 tenths. So this is going to be equal to 2 and 5 over 10, which of course we can write as 2.5 or 2 and 5 tenths. So 500 divided by 200 is 2.5. Let's do another example. Let's say we wanted to figure out what 0.63 divided by 0.07 is. Pause this video and see if you can come up with a strategy for doing this. Well, there's multiple ways to tackle it. One way is to think about both of them in terms of hundredths. So, for example, this is 63 hundredths. And this right over here is 7 hundredths. And so if you have 63 of something and you're dividing that by 7 hundredths, what are you going to get? Well, you're going to, if you took your 7 hundredths and you multiply it by 9, you're going to get 63 hundredths. And so 63 of something divided by 7 of that same something is going to be equal to 9. This is going to be equal to 9.
Why not
7
900?
times 9 is 63. So 7 hundredths times 9 is going to be 63 hundredths. Another way to think about it is we can express this as a fraction. So in the numerator you have 0.63, and in the denominator you have 0.07. And if the decimals are bothering us, we can multiply both the numerator and the denominator by the same value to get rid of the decimals. So let's multiply the numerator by 100 and also multiply the denominator by 100. This doesn't change the value of the expression because multiplying by 100 over 100 is just the same thing as multiplying by 1. So this would be equal to 63 hundredths times 100. Well, we would move the decimal 2 to the right. This is going to be equal to 63 over 7 hundredths times 100. Once again, we move the decimal 2 to the right. This is going to be 7. So 63 divided by 7, once again, that is going to be equal to 9.
Holy shit, it's a fuck ton of videos.
Let's do a few more examples of thinking of strategies for dividing decimals. In the future, we're going to come up with a more systematic way of doing it, but it's really important to come up with some of these strategies because it gives you an intuition for dividing decimals, and frankly, it's an easier thing to do, especially when you're trying to eventually divide decimals in your head. So let's say we want to figure out what 6 divided by 0.2 or 2 tenths is. Pause the video and see if you can figure it out. So we've already explored multiple strategies. One strategy is, well, let's express this as a fraction. This is the same thing as 6 over 0.2. And maybe we can multiply the numerator and the denominator by some value so we're not dealing with decimals anymore. And if you want to get rid of the decimal on the bottom, we have 2 tenths. Well, we can multiply the bottom by 10. But if we multiply the bottom by 10, we need to multiply the numerator by 10. So it's essentially we're multiplying this fraction times 10 tenths, which is just multiplying it by 1, so it doesn't change its value. So this is going to be equal to 60,
divided
so
by
6, 0, over 2 tenths times 10. That's going to move the decimal 1 to the right, and that's just going to be equal to 2. Now, what is 60 divided by 2? Well, 60 divided by 2 is fairly straightforward. 6 divided by 2 is 3, so 60 divided by 2 is going to be equal to 30. So that's 30, and so we're done. Now, another strategy is you could have thought of all of these numbers in terms of tenths. You could have said this is 6, let me do that orange color. You could have said this is 6 tenths divided by, oh, let me be careful. This is 60 tenths. 6 is 60 tenths. 60 tenths divided by 2 tenths. 2 tenths is equal to, well, I have 60 of something, and if I were to divide it into groups of 2 of that something, I would have 30 groups. That's going to be equal to 30. Let's do another example. This will be our most involved one before we really try to show you the standard way of dividing decimals. Let's say we wanted to compute 4.2, or 4 and 2 tenths, divided by 3 tenths. Pause the video and see if you can figure that out. Well, you've already seen multiple techniques for tackling this. It never hurts to try to write this as a fraction. So this you could write as 4.2 divided by 3 tenths. And now we could try to get rid of the decimals. Now the best way to do that, I could imagine, I have tenths here, I have tenths here. If I multiply the numerator and the denominator by 10, that might help out a lot. Because in the numerator, this would move the decimal 1 to the right. So in the numerator, I would get 42. 4.2 times 10 is 42 over 3 tenths times 10. Well, that is going to be equal to 3. And so what is 42 divided by 3? Well, there's multiple ways to do that. You could try to do it in your head, or you just try to actually do a little bit of medium-long division. It shouldn't be too long. So let's see. 3 goes into 4 one time. 1 times 3 is 3. Subtract. 4 minus 3 is, oh, why did I write 43? I knew something was fishy. 42. 3 goes into 42. My brain is malfunctioning. All right. 3 goes into 4 one time. 1 times 3 is 3. You subtract. 4 minus 3 is 1. Bring down the 2. 3 goes into 12 4 times. So this is equal to 14. And so this one right over here is going to be equal to 14. And just like we saw in the last example, you could also think of this as 42 tenths. 42 tenths divided by 3 tenths. Divided by 3 tenths. In which case, 42 tenths, 42 of something divided into groups of 3 of that something, you're going to end up with 14 groups. You're going to end up with 14. So hopefully you appreciate these ideas. Express it as a fraction. See if you can multiply the numerator and denominator by the same value, so maybe the decimals get eliminated. Maybe you can think of these numbers in terms of tenths or hundredths, and then think of it that way. And any of these combinations are going to be effective strategies, or hopefully effective strategies, for dividing decimals or dividing numbers where the quotient might be a decimal. And in future videos, we're going to learn a more standard, systematic way of doing it. But this is always valuable. You'll see, if someone walked up to me on the street and said, "What's 4.2 divided by 0.3?" This is how I would actually do it. I would say, okay, that's the same thing as 42 divided by 3. And then I would say, okay, 3 goes into 42. Let's see, 3 times 10 is 30, and then 3 times 4 is 12. Yeah, that would be 14 times. That's how my brain would do it if I was trying to do it in my head. Let's figure out what 6.3 divided by 0.25 is. And when I look at something like this, the first thing that I think about is, well, is there a way that I can rewrite this? So instead of dividing it by 25 hundredths, instead of dividing it by 0.25, I could divide it by a whole number, maybe 25. And so how do I turn 25 hundredths into 25? Well, if I multiply by 10 once, then the decimal moves 1 spot to the right. And if I multiply it by 10 twice, then I'm going to move 2 spots to the right, and 25 hundredths is going to become 25. I multiplied by 10 twice, which is the same thing as multiplying by 100. Now, of course, I can't only do it to 0.25. That would change the value of this entire expression. I also have to do it to 6.3. If I move the decimal to the right twice over here to get a whole number, I got to move the decimal twice to the right over here. So let's see. If I move it to the right once, I get 63. So that's one multiplication by 10. And now I want to move it to the right again. And you might say, wait, there doesn't look like there's any other digit here that I can move to the right of. And we just have to remind ourselves that 6.3, well, that's going to be the same thing as 6.30. Or we could actually add as many zeros as we want to the end of this and not change the value. It's still 6.3. 6 and 3/10 is the same thing as 6 and 30/100. So now I can move the decimal one more spot to the right. And so I'm multiplying by 10 again. And it becomes 630. So 6.3 divided by 0.25 is the same thing as 630 divided by 25. Let me do that again, because this is really the tricky part, or the artful part, when you're dividing decimals. If I were to write 0.25 being divided into 6.3. Let me do it. 6.3. Now what I care about is moving this decimal to the right far enough so that this becomes a whole number. I don't have to move it any further, just far enough so that this becomes a whole number. And then I have to move this the same number of times to the right. But the goal is to make this a whole number, not to make the 6.3 a whole number, although that is going to happen for this particular case. So if I move it 2 spaces to the right, so 1, 2, 0.25 becomes 25. And then 6.3 becomes, move it 1 space, 2 spaces to the right, it becomes 630. And so let me clarify that. Let me just clear all of this stuff out of the way to just make that clear what I just did. So we don't have to deal with all this messiness when we're actually doing our long division now.
63 divided by 25 and just do the number of
this business. And we are ready to do some. We're ready to do some long division. All right. So now this is just straightforward dividing a 2-digit number into a 3-digit number. And so we could say, well, 25 goes into 6 0 times. So let's keep going. 25 goes into 63. Let's see. 2 times 25 is 50. 3 times 25 is 75. So that's too much. So we want to go 2 times. 2 times 25 is going to be 50. And we can subtract. Or if you didn't know 2 times 25 was going to be 50, you could have said 2 times 5 is 10. Carry the 1 or regroup the 1. 2 times 2 is 4. Plus 1 is 5. So we got 50. And now we subtract. And we get 3 minus 0 is 3. 6 minus 5 is 1. And now we bring down the next digit. We can bring down this 0. And we could say 25, and let me scratch this out so I don't confuse myself later. 25 goes into 130 how many times?
5 times.
Let's see, 25 times 4 is 100. 25 times 5 is 125. 25 times 6 would be 150, so that's too big. So I'm going to go 5 times. So 5 times. And I write, it's very important to keep track of my places right here. I brought down the 0 to make the 13 into 130. So when I say 25 goes into 135 times, I write it above the 0. I write it right above the 0 right over there. And then 5 times 25, 5 times 5. We already know what it is, but I'll just figure it out. 5 times 5 is 25. Regroup the 2. 5 times 2 is 10, plus 2 is 12. And now we can subtract. And you might know offhand, well, yes, 130 minus 125 is going to be 5. Or if you like, you could do a little regrouping. You can make this, you could take a 10 from there and then put the 10 in the ones place, and this becomes 10. 10 minus 5 is 5. Now, we aren't done yet. We want to divide this completely. So we can bring down another 0. We can bring down another 0, and I'm picking an appropriate color for the next. Well, I already used the green once. We'll use yellow. So once again, I can bring down another 0, but I have to be very careful here. I can't just throw a 0 right over there. That's going to turn 630 into 6,300. I have to be very particular. Say, no, look. This next 0 I'm going to put, that's going to be after the decimal. Now, 630 is the same thing as 630.0. And if I'm going to add a decimal there, I want to throw the decimal right above it. You need to be very careful with that. But now we're ready to start bringing down the 0. So let's bring down this 0. And we have 50. How many times does 25 go into 50? Let me scratch this out so we don't confuse ourselves later. 25 goes 2 times into 50. 2 times 25 is in fact 50. Is in fact 50. And so now we can subtract. And we now have a remainder of 0. And there's nothing left to bring down other than zeros. And we have a remainder of 0. So we are done dividing completely. You take 630 divided by 25, it's 25.2. Or if you look at our original problem, which was 6.3 divided by 0.25, that also is 25.2. So this is also going to be 25.2. Let me rewrite it. So our original problem was 6.3 divided by 0.25, which we just figured out is 25 and 2/10. And we're done. Let's see if we can divide 30.24, divide it by 0.42, and try pausing the video and solving it on your own before I work through it. So there's a couple of ways you could think about it. We could just write it as 30.24 divided by 0.42. But what do you do now? Well, the important realization is when you're doing a division problem like this, you will get the same answer as long as you multiply or divide both numbers by the same thing. And to understand that, we could rewrite this division as 30.42 over 0.42. We could write it really as
30.42.
a fraction. And we know that when we have a fraction like this, we're not changing the value of the fraction if we multiply the numerator and the denominator by the same quantity. And so what could we multiply this denominator by to make it a whole number? Well, we could multiply it by 10 and then another 10. So we could multiply it by 100. So let's do that. If we multiply the denominator by 100, in order to not change the value of this, we also need to multiply the numerator by 100. We're essentially multiplying by 100 over 100, which is just 1. So we're not changing the value of this fraction, or you could do this of this division problem. So this is going to be 30.42 times 100. Move the decimal 2 places to the right, gets you 3,042. The decimal is now there if you care about it. And 0.42 times 100, once again, move the decimal 2 places to the right. It is now 42. So this is going to be the exact same thing as 3,042 divided by 42. So once again, we can move the decimal here, 2 to the right. And if we move that 2 to the right, then we can move this 2 to the right. Or we need to move this 2 to the right. And so this is where now the decimal place is. You could view this as 3,024. Let me clear that. 3,024 divided by 42. Let me clear that.
That's what I did.
And we know how to tackle that already, but let's do it step by step. How many times does 42 go into 3? Well, it doesn't go at all, so we can move on to 30. How many times does 42 go into 30? Well, it doesn't go into 30, so we can move on to 302.
Now we're going to do
How many times does 42 go into 302? And like always, this is a bit of an art when you're dividing by a 2-digit or a multi-digit number, I should say. So let's think about it a little bit. So this is roughly 40. This is roughly 300. So how many times does 40 go into 300? Well, how many times does 4 go into 30? Well, it looks like it's about 7 times. So I'm going to try out a 7, see if it works out. 7 times 2 is 14. 7 times 4 is 28. Plus 1 is 29. And now I can subtract. To do a little bit of regrouping here. So let's see. If I regroup, I take 100 from the 300. That becomes a 200. Then our 0 tens. Now I have 10 tens. But I'm going to need one of those 10 tens, so that's going to be 9 tens, and I'm going to give it over here. And so this is going to be a 12. 12 minus 4. 12 minus 4 is 8. 9 minus 9 is 0. 2 minus 2 is 0. So what I got left over is less than 42, so I know that 7 is the right number. I want to go as many times as possible into 302 without going over. So now let's bring down the next digit. Let's bring down this 4 over here. How many times does 42 go into 84? Well, that jumps out at you, or hopefully it jumps, or it starts to, it goes 2 times. 2 times 2 is 4. 2 times 4 is 8. You subtract, and we have no remainder. So 3042 divided by 42 is the same thing as 30.42 divided by 0.42, and it's going to be equal to 72. It's going to be equal to 72. Actually, I didn't have to copy and paste that. I'll just write this. This is equal to 72. This is equal to 72. 72. Just like that. Let's figure out what 2.211 divided by 6.7 is. So the first thing I like to do is I don't like to divide by a decimal. So I'm going to multiply 6.7. I'm going to multiply 6.7 by 10, which is essentially just taking this decimal and moving it one space to the right. Well, I can't just do that to the 6.7. I also have to do that to the 2.21. So let me move its decimal one space to the right. And so now I can rewrite the problem. I can rewrite it as 22.11 divided by, instead of writing it as 6.7, I can now write it as 67. 67, let me do it in that same color. I can now write it as 67. Now I could write a decimal right over here, but that's not going to change the fact that this is just now the whole number 67. And so now I'm ready to do some long division, now that I'm dividing by a whole number. You might say, wait, I still have a decimal over here, but that's okay, and you're going to see that in a second. So let's try to do some long division. So we're going to take 22.11 or 22 and 1100ths, and we are going to divide it. Let me write that a little bit bigger, just so we have some space. 22.11, and we are going to divide that by, 67. 67. All right, let's do some long division now. And actually, before we even do that, I like to keep track of my decimal. So my decimal is over here. I'm going to write my decimal right over here in the answer. And when you're doing these long division problems, it's really important to write things neatly and keep things in nice columns and keep track of your place value, because if you don't write things in neat columns, then frankly, you'll probably lose track of your place value. But let's do this. So 67 goes into 2 0 times. So let's move on. 67 goes into 22 0 times. 67 goes into 221. So let's think about that a little bit. This is pretty close to 70. 70 times 3 would be 210. So this looks like maybe 3 times. 3 times seems about right. So let's try. Let's put a 3 up here. 3 times 7 is 21. Carry the 2. 3 times 6 is 18. Plus 2 is 20. So we get 201. And the difference between 221 and 201 is going to be, well, you just get a 0 here, you get a 2 here, and then you get a 0 here. I don't have to write it. It's 20. So 3 was right. If 3 times 67 were higher than 221, then we'd be in trouble. And then if 3 times 67 were lower, but it was so low that when you subtracted, you got a number higher than 67, then that means you could have thrown in more 67s in there. But this number is just right. It's lower, but our remainder is less than 67. So let's keep going. So now we can bring down the 1. And we see 67 goes into 201. Well, we just figured that out. 67 goes into 201 3 times. 3 times. 3 times 7 is 1. Carry the 2. Got to make sure we don't, well, we're doing the same problem as we did before, but it's good to not have the previous 2 there. Sometimes you might want to erase it. Then you have 3 times 6 is 18, plus 2 is 20. And now you subtract, and we are done, because we have no remainder, and there's nothing here left to bring down. And so 22.11 divided by 67 is, and we could throw a 0 here just for good measure, it's 0.33. 0.33. This is equal to 0.33. Or this is equal to 0.33. And we're done.
We need to divide 0.25 into 1.03075. Now, the first thing you want to do when your divisor, the number that you're dividing into the other number, is a decimal, is to multiply it by 10 enough times so that it becomes a whole number, so that you can shift the decimal to the right. So every time you multiply something by 10, you're shifting the decimal over to the right once. So in this case, we want to shift it over to the right once and twice. So 0.25 times 10 twice is the same thing as 0.25 times 100, and we'll turn the 0.25 into 25. Now, if you do that with the divisor, you also have to do that with the dividend, the number that you're dividing into. So we also have to multiply this by 10 twice, or another way of viewing it is shift the decimal over to the right twice. So we shift it over once, twice, it will sit right over here. And to see why that makes sense, you just have to realize that this expression right here, this division problem, is the exact same thing as having 0.25 is the exact same thing. Let me make it. Is the exact same thing as having 1.03075 divided by 0.25. And so we're multiplying the 0.25 by 10 twice. We're essentially multiplying it by 100. Let me do that in a different color. We're multiplying it by 100 in the denominator. This is the divisor. We're multiplying it by 100. So we also have to do the same thing to the numerator if we don't want to change this expression. We don't want to change the number. So we also have to multiply that by 100. And when you do that, this becomes 25, and this becomes 103.075. Now let me just rewrite this. Sometimes if you're doing this in a workbook or something, you don't have to rewrite it as long as you remember where the decimal is. But I'm going to rewrite it just so it's a little bit neater. So when we multiplied both the divisor and the dividend by 100, this problem becomes 25, 100. So when we multiplied both the divisor and the dividend by 100, this problem becomes 25 divided into 103.075. These are going to result in the exact same quotient. They're the exact same fraction if you want to view it that way. We've just multiplied both the numerator and the denominator by 100 to shift the decimal over to the right twice. Now that we've done that, we're ready to divide. So the first thing, we have 25 here, and there's always a little bit of an art to dividing something by a multiple digit number. So we'll see how well we can do. So 25 does not go into 1. 25 does not go into 10. 25 does go into 103. We know that 4 times 25 is 100. So 25 goes into 103 4 times. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 100. We knew that. 4 times 4 quarters is $1, is 100 cents. And now we subtract. 103 minus 100 is going to be 3. And now we can bring down this 0. So we bring down that 0 there. 25 goes into 30 one time. And if we want, we can immediately put this decimal here. We don't have to wait until the end of the problem. This decimal sits right in that place, so we could always have that decimal sitting right there in our quotient or in our answer or our quotient. So anyway, we were at 25 goes into 30 one time. 1 times 25. 1 times 25 is 25. And then we can subtract. 30 minus 25, well, that's just 5. I mean, we could do all of this borrowing business or regrouping. This can become a 10. This becomes a 2. 10 minus 5 is 5. 2 minus 2 is nothing. But anyway, 30 minus 25 is 5. Now we bring down, now we can bring down this 7. 25 goes into 57 2 times, right? 25 times 2 is 50. 25 goes into 57 2 times. 2 times 25 is 50. And now we subtract again. 57 minus 50 is 7. And now we're almost done. We can bring down this 5. we bring down that 5 right over there. 25 goes into 75 3 times. 3 times. 3 times 25 is 75. We say 3 times 5 is 15. Regroup the 1. We can ignore that. That was from before. 3 times 2 is 6, plus 1 is 7. So you can see that. And then we subtract. And then we have no remainder. So 25 goes into 103.075, exactly 4.123 times, which makes sense because 25 goes into 100 about 4 times. This is a little bit larger than 100, so it's going to be a little bit more than 4 times. And that's going to be the exact same answer as the number of times that 0.25 goes into 1.03075. This will also be 4.123. So this fraction, or this expression, is the exact same thing as 4.123. And we're done.
Yeah, final video.
In this video, we're going to get a little bit of practice multiplying and dividing decimals by 10, 100, and 1,000. So let's just start with a little bit of a warm-up. If I were to say, what is 2.05 times 10? Pause this video and see if you can figure that out.
Like 20.5.
Well, in previous videos, we've already said that when you multiply by 10, you shift each of the digits one place to the left. And so this is going to be equal to, instead of 2 ones, we're now going to have 2 tens. So 2 in the tens place. And then instead of 0 tenths, we're now going to have 0 ones. And instead of 5 hundredths, we're now going to have 5 tenths. So this is equal to 20.5. Now what if we were to go the other way around? What if we were to say 2.05 divided by 10? Pause the video and see if you can figure that out. Well, here, all of our digits are going to shift one place to the right because we're dividing by 10. We could also view that as multiplying by 1/10. And so our 2 ones are going to become 2 tenths. So this is going to be 0. So we're going to have 2 tenths now. Our 0 tenths are going to be 0 hundredths. And then our 5 hundredths are going to be 5 thousandths. And we've covered that in other videos. But now let's do this with, say, 100 or 1,000. So if I were to ask you, what is 57 divided by 1,000? Pause this video and see if you can work that out. All right, now let's do this together. So when you divide by 1,000, that's the same thing as dividing by 10 3 times. Or it's the same thing as multiplying by 1/10 3 times. Or you could just say, hey, that means I'm going to shift each of these digits 3 places to the right. And so let me create some places here. So that's tens, ones, tenths, hundredths, thousandths. And so our 5 was in the tens place. It's 5 tenths. So it was here. But we're going to shift 3 places to the right. 1, 2, 3. So our 5 will go there. So what was 5 tens is now 5 hundredths. And then our 7 is similarly going to, it was in the ones place, but we're going to shift 3 places to the right. 1, 2, 3. And there you have it. What was just 57 is now 57 thousandths. And to make that very clear, I'll put a 0 in the tenths place and a 0 in the ones place. And that makes sense. So as another example, let's say someone walks up to you on the street and says, I started with 1.032 and I multiplied it by something and I was able to get 103.2. What did they multiply by to get 103.2? Pause this video and try to work it out. Well, to understand this, we just have to think, well, how much did each digit get shifted by? So what was in the ones place got shifted not just to the tens place, but it got shifted to the hundreds place. So it got shifted 2 places to the left. The 0 similarly got shifted 2 places to the left, from the tenths to the tens. And if you look at it, every digit got shifted 2 places to the left. And so we must have multiplied by 10 twice. So you could say times 10 times 10, or you could just rewrite this as times 100. Let's just do one more example for kicks. Let's say that someone were to say, what is 0.015 times 100? Pause this video and see if you can figure that out.
1.5, right?
All right. Well, like we've done before, we're just going to shift every digit 2 places to the left. So the 1, which is in the hundredths place, is going to end up in the ones place. And then the 5, which is in the thousandths place, is going to end up in the tenths place. So this is going to be equal to 1.5. And we're done.
Nice. Yo, this is it, and it's not making a mistake. I am not to afford a mistake here. Yo, it's gonna be a lot. I'm having a coffee. I'm gonna make more coffee. Just a second, I'm just gonna brew some coffee. Right, I'm back. Let's do the thing. Okay. Wait, what? What was this already answered? Okay. Dividing whole numbers by decimals visual. Oh gosh, this is hard. Oh crap, it's gonna be 8, right? Oh no, my gosh. Let's try it. Let's go with 5. It's 4. No, 4 divided by 5, right? Yeah, it's gonna be. Okay. Yo, visual is hard with visual stuff. This slot 7. How many 7s are this? 1. This is like 7, and then in each of us 28. 28. Not 28, but you know what? We're gonna do the thingy anyway. Divide by 25. So 700. Yo, what the fuck? I get 5. No, why did I say 5? It's 2. 50. It's gonna be 20. And then it's gonna bring up 0. It's gonna be. So what's this? Let's go 4, 8, 1. Right? And 8. It's good. This is the number line of visual C divided by 0.5. So 1, 2, 3, 4, 5, 6. 6 divided by 4. Oh shit, it's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. Yo, is it 14? Yeah, let's try it. 15. So 6. This is 60 divided by like 4. And then let's have 2 times. Oh, 2 times just 1. 1, 4, 2, 25. Let's do a little 15. Oh. Divide decimals by whole numbers visual. You missed the model, so help find it. Yo, it's gonna be 0.44, right? Like, jumps like that. Let me do that. Okay. But if I like do it like 88, divided by 2. Yo, so 0.88 to 5 by 0 times. Now let's go like 2 times like 4, 2 and 8. Use the number able to divide 1 into 5 equal sized groups. 1, 2, 3, 4, 5. Yo, it's worth 1, 2, 3, 4, 5. 60 divided by 5 is 5. Yo, no. Like if you do it in this way, 5, then we're gonna go discount 1. 5 with 1 and 12, 0.12. Right? This must make more sense, but 0.12. So there. So this means each jump is a 12. Okay. 0.6 divided by 3. We have 2.2. This has 6 and 0. 2. It's reasonable. It's gonna be like 0.8, right? 4. And it goes third, like it goes into third to like 8 times. Oh shit. Oh bitch. Okay. 4 divided by 25. We want to be like. So we're gonna make this 400. Add this. Right? Okay, so it goes into that guy one time. We have 25. So we have 15. That guy. And I guess it's goes 6 times. I lost my I just I've lost my will to live because I made a mistake. 600 divided by 25. We have 2 here. That's 50, 10, 4, and 4. 9. 90 divided by 6. 1 times 6, 3. 30, 5, 15. And this one we have 10 divided by 5 plus 2 times, it's 1,000. And then like it goes around 4 times. So we have 100, 0, like 0 here. So in 0, and 0, and 4. Then we have 9. It's like 90 divided by 5. Or 18, right? So if you divide by half, it's like multiplying by 2. So you have to divide by 5, 2 times 100, like 8. Then we can try again. Okay. We have 20. 4, 5, please. Oh shit, wow, okay. You have 6 divided by 6. 1 times 6, 0, 0 times 10. So you have 3, let's say 300 divided by 75. It goes, oh shit, It's actually 4, right? Okay. So we have 40 divided by 2. Oh shit, I'm pretty good idiot. Let's try again. Now we have 40 divided by 2 times 4, 0, and 0 times only 0, 0, 800 divided by 5. So it goes to 80 like 3 times, so you get 75, you get 50, and you get that, and you get so like 2 times. Yeah, so I was multiplying by 4. Oh shit, it's gonna be 100, right? Let's try. 100 divided by 1. That's insane. Dividing decimals too. Ah, shit. Then, but to be sure, we have 30 divided by 3 to 1. Okay. Okay. 2 divided by 0.8. 2 divided by 8. 8. Okay. No, 2 times like 16. 4, 40, 5. Yeah. We have 80 divided by 4. 8, 0, 0, 0, 0, 0. So we have like 10. 100 divided by 4. But goes to like 2 times 8 and then 2, 3, 5. 5 piece? Shit, I don't want to make a mistake. It does look like 25, but let's try again. 100 divided by 4, right? 100 divided by 4. We 2 times get 8. We back that, we get 2 and we get 5. Then, 50 divided by 4, 1 time, 4, 1, 10. So we have 2 decimal in here, 8, 20, 12, 19, like 4, 2 times 8, 1, 10, 2, 8 again, and 20, 5 of those, at least. Thank you. Awesome, awesome, awesome. Hundreds, hundreds. Okay. Oh shit. So we have 115 divided by, right? 1, 2, 20, 1, 2, 17. So, let's say, I think 4 is a good number. 12. 12, right? 4, 8, 9. 92. So we have 3, 11, and we have, exactly those 5 points. Yeah. So, divided by 43. 1, 1, 18 goes into this guy like 3 times 1, right? So we have like 86, maybe 11, 5, 10, This one's nothing more. Yeah. Oh yeah, it's gonna go like that. Bring down that guy. So let's see how many times. We have like 40, and then 250. Let's try like 5. Let's go on 5. Let's see if that's good. 15, 4, 21. What if by 6? You have 18. But 24, 25. Oh shit, 6 times. Uh, 8, 8 divided by 6. Who goes 1 time? 6. It's like 7. 7. Bring down that guy. We have 78. I guess it goes 3 times. Yeah, definitely 3 times. So 18. 18, 6, 7, 8, so 18. So we have 1968 divided by 4. So we're gonna do the arty thing again. So we have like, what is this? 24, 1. Or this plus 1, it's plus 5. So what if I say like 25, 4, 8? What if I 8 times? So 4 times 8 is 32. 2, 3, 8, 16, 17, 18, 19. 190. No, 4. We got that. So this is 2. 82. Let's go 82. Oh crap, I don't want to make a mistake, but it seems in line. Oh shit, thousands. Real big number. 4, 1, 5.01 divided by 47. Let's sing it this way. 47, then 400. Oh shit. We also say, what if we try like 47 times 9? 3, 6, 36. Oh, it's too much. Wait, what? Oh yeah, it's too much. 36. Oh shit. Let's go 8 times. Wait, what? Where was I? 47. 47 plus 8. 6. 5. 32 and then 37. Let's try 8. Then of course the brothers are 6, 5, 32, 37. 15. And we have like 10. So that's 3. 15 and it's 9. 39. Where's here? 39. Oh shit. We're gonna do 8 again. 3, 7, 6. Then 4, 8, 1. And then should we bring some? We bring some. 41. I guess it's 3 times, right? Makes sense. 47 times 3. 1, 2, 12, 14. Okay. 8.8 please. Such a big number, man. Bigness. 3.162 divided. So it doesn't go into that one, it doesn't go into the third one. So it's here. Let's see. It goes to 316. 316. So 5 is 25. 5, let's try by 51 times 6. Let's try 6. 6 and then 306. Okay, so 306. So we have 0 and then 1 and 102. 6, right? 6. Then twice. 0.016. I've failed this part. Okay. 9.882 cents divided by. Doesn't go in there, just go into this guy one time. You have 81. Then 7, okay, 17. Then bring down this guy. Then let's say 2 times. It's going to be like 162. Correct? That's correct. 162. 2 and 16. Yeah. So let's say we're gonna get like 6 and 16. Now 6 to this, we get 8 and then 1, 7, 16. Remember, bring down 2. So I guess this is 3 times, but not really. Oh shit, this is really nice. Oh shit, wow, it's pretty cool. Okay, we're gonna move the guys to 2 places. 193.2 divided by 2. This is correct. 1, 2, 1 to 109. So it goes into 2 times, so we're gonna have times. So let's try 22 times 8. Well, it's gonna be 4. 2, 18, and it's too much. Let's go with 7. 21, 1, 2, 14, and 16. Right? 2 and 3. But 32 is larger. What the heck? This is what I'm adding here. 20 times 8. 4. 2, right? 16, 17, 18. Holy shit. 8 and 4. 2 there. 8. No, 16, 17, 18. 13. 13. What are they? 9, right? Just add 9 to this and give it 9. Remember being empty. And for that to happen, like 23 times 4, so 12, 4, 8, 9, 8, so 9. So yeah, it's gonna be like 4, 8 and 4. Is it 4? Yeah. Now we're gonna do the quiz. Even though I don't have to, we're gonna do the quiz. And if I make a mistake, I'm gonna level down one of these. And it's gonna be a very lengthy process. But sure. Oh, that's a monster piece. Let's just not make any mistake. This is insanely hard. 10 problems. 184 times 251. 184,251. 4, 8, we have 1. We have 20, 22, 42, 2, 4, 5, 9. Okay, so we have 2 zeros here. So 2, we have 8. 2 times 4, 8. 2 times 8, 16. 2 times 1 is 2, plus 1 is 3. Add them all up, we have 4, 8, 11, 10, 16, 4, 6, 1, 8, 4. Decimals 1, 2, 3, 4, 6. And yeah, cool. Multiply. Ah, shit. Gonna be go down, right? 1, 2, 2, 2.01. Oh shit. Crap. I multiply this by. Okay. We just do like 1, 2. Like, yo, it should be this one, right? I mean, like 201 multiply. Uh, I mean, if you do this, like 2 into 1 is 1, same thing. Then how many decimal places do we have? 2. Yo. No, I didn't press it. Ah, I did an accident. I didn't mean to press it. Fucking hell. Ah, it's 30 minutes gone. Eight times 4. 8 times 2. 3. 3. 16. 16. 1, 8, 9, 4. 0. 16. 3. Oh, not 16. Dude, I'm losing my shit. I made a mistake. Um, oh shit, it's division. 12, 4.08 by 44 time 124.08 divided by 4. So we have 14, 14, 6, 11, 3, 36. Dropped up. Took a 5 down. 6, 2, and like 4. How many times do I need? This was 15. Oh, went 7. Let's try 7. 8. Okay, it's 44. We got like 12. 5. Still 8. Let's do 8. So 8 times 4 is 32. 8 times 4 is 32. Plus 3 is 35. With 10. With 8. With 5. So we get 9. 9, 8. Yeah. So we have 8 and 2. 2.83. Okay. This is gonna be 2, 7, 2, 47, 56, 60, 18, 10, 11, 10, 11, 17, 2, 15, 2, 11, 2, 1, 2, 5 point. What experiment can we represent with the following model? Each large square represents one whole. 0.5 times 3. 1, 2, 3, 4, 5. You may use the models. Four to 2 divided. 1, 9. 3, 1, 4. Yo, it's for real. 0.14. 64 times 50. 64, 53. 12. 20. 2, 32, 52, 9, 83, 92, 1, 2, 3. 1, 2, 3. 1, 2, 4.7 times 1.5. 4.7 times 1.5. Okay, since by a lot of numbers, so 500 divided by 250, 0, 0, right? 4, the digits are 5 seconds. No level down, please. No level down. No level down. Where's that? Down. That's gonna be 5.5. It's gonna be 1%. What? Is this wrong? Times 1, right? So 7.9. Why is this wrong? I mean, like 379, then times 1. You have 379. You like 2 places to the left. Oh shit. It's 379. 9.5. No way. 1, 2. Shit. $282 times 400 for fucking hell. 182 400. 4, 16, 4, 5, 8, 2, 3, 8, 11, 4, 8, same shit, I guess. 4, 8, 32, 3, 8, 9, 10, 11, 4, 14, 6, 14, 16, 4, 2, 1, 1, 2, 4, 6, 4, 4, 1, 2, 3, pain. Okay. Julian was at 65 times 4, 9. This is understand of the result. Oh, okay. So 6.5. You can remove one guy left, so we have 331,000. So we move that guy one place to the left. So we're supposed to have one guy on the right hand. Oh shit, what's this again? 1, 2, 0.8. Please, we are 0.8. I mean, like, we have 80, and then like, this one's 2 places. So we have supposed to have 2 guys. 0.8. Oh, it's giving range time. I don't want to mess this up, please. I just had this finished earlier. I mean, it is like times 1, but times 0.1, 0.8. Damn, it's giving me the goosebumps. It's giving me one kill myself. 52, 52. 18, right? 9, 18, 2, 0, 1, 8, 12, 0, 4, 5, 4, 20, 30, 8, 6, 12, 3, 3, 3, 3, 3, 2, 6, 8, and there are decimal plus like 2 digits. Just to be sure, we're going to do it again. 6409 times 52. 6409 plus 18. 18, nothing. 201, 8, 16. Yo, why is it 16? It's 12. 18, 0, 1, 8, 4, 5, 4, 5, and 20, 32, 8, 6, 2, 3, 3, 3. Each large square is a whole. Which multiplication equation best represents the figure? Shit. Times. What's this? Let's say 4. 46. 3 times 46. So, am I supposed to say 5? 4D divided by 8 is in that's 15. And we have two guys. So one. So yeah. 8 to 16. Oh shit. I'm getting distracted that time. 16, then 11, 2, 3, 8, 5, 1, 6, 8, 8, 1, okay, 18, 6, 18, 1, 5, 8, 12, 16, 10, 11, 2, 3, 8, 5, 1, 6, 9, 8, oh shit, 18, 3.478 divided by 37, 0.34. Let's try 9. 9. It's gonna be like 63. 3, 6, 8, 27, 27, 33, 4, 1, then side 3 times. I was gonna put these 4 times. 37 times 4, 28, 2, 12, 14, cool. 0.094. Use a number line to divide 0.14 into 3 equal sized groups. 0.4 divided by 3. So we have 0 here, and then 1 time here, and we have 3, 1, 12, 18, and 6. Finally, the unit test. And 4 hours in. Oh shit. 30 questions. Okay. You may see what else shown to find the difference. Okay, difference. Okay. Okay, so we have 0.84. Oh crap, I kind of forgot if we did some technique or anything. It's 2 and 6.62, right? Oh my god. I'm getting paranoid and stuff. 0.84 minus subtract. So 2 and then 6, 0.62. Then we have 74. Let's try the bigger number first. 422, 74. 422 times 74. Okay. We have 8 and another 8, and we have 16. 0 here, we have 7, 14, 15, 7, 8, 29. 8, 12, 12, 10, 11, 3, 1, 2, 8, then it's gonna have like 5, 1, 2, 3, 4, 5. Oh shit. Okay, which of the following numbers round is explained if we're rounding to the nearest hundredth? Nearest hundred, this is 100, 8. Oh shit, what? What? Oh my gosh. 8, and what is to the left of that? I don't know what's to the left of that, dude. It should stay the same as 6.8. Oh, okay. I'm actually looking for one of these that would result to 6.88. Is that it? Is that it? Which are the following numbers from? Oh, right. 6.8 if we round the nearest 100. That's going to be 8. 6.83. Okay, it's going to round down to 6.88. And then 6.75 is going to round up to 6.8. 86 times 20. 86, right? So 86 and we have 12, 16, 17, 12 again, 16, 17, 2, 7, 9, 8, 1, 1, 8, 9, 2, and then 1, 2, 3. Then again, I'm paranoid, so we're gonna restart shit. We have 12, 18, 17, 0, 12, 16, 17. We have 2. What is this? It's 2, right? 9. 8, 1, 8, 9, 2, 1, 8, 9, 2, and 2, 8, 9. Express the shaded areas both a fraction and a decimal. Oh shit, this is hard. Yo, 1, 2, 3, 4, 5. It's a fraction 5 over 100. It's 5. 5 hundredths. 1, 2, 3, 4, 5. It's a fraction of 100. Oh man, I can't afford to make a mistake. Which of the following area are equal to 1? Choose two answers. 1, 2, 3. This one's 1.3. It's 1.3. 13 hundredths. No. It's going to be 0.13. Yeah. Two answers. So what is right for the 7 hundredths? This decimal. 0.47. 47 hundredths. 10 hundredths, 47 hundredths. It's 8. What is this even supposed to mean? Okay, so we have like 40, right? Oh no. 40 divided by 5. By 50. Oh. 0. Divided by 5. 0. That's gonna 0. How am I doing? 48. What for divided by 5? That makes sense because 19 times 8.3. 8.3. 10, 9, 19. 8.3%. Just one answer. 5, 1, 6, 4. 12, 2, 3, 8, 9, it's 10. It's 10. 0, 4. What's this gonna be? 4, 2, 4, 6, 20. 2, 7, 6, 1, 2, 1, 6, 7, and 1 is this. That's correct. In which number does the digit 4 have a value? 1 times the square root. Oh shit, what does this mean? In which number does the digit 4 is 10 times great as the digit 4 in the number 3, 8, 4, 6, 8? In which number does the digit 4 have values 0.10 times its great? So I guess it's not the answer. So we're gonna have like 0.3. Oh shit. 4 in the thousands place. That's why. Let's do this again. In which number does the digit 4 have a value is 10 times a 10 times great as the port in the number 3486. If this one is 10 times, then it will land in this spot 10. That's correct. It's 1. It's 1. The 2. Yeah. 1, 1, 2, 2, 3. Which express shaded there is both a fraction and a decimal. There's 2 and there's 1, 2, 3, 4, 5, 6, 7, 7. 74 over 109. It would be 74. Would be correct, this is 74. Yes, it's 8. It's 9, 10. Wait, did this show? 1, 2, 3, 4, 5, 6, 74. 2, 74, 100. Decimals to 74. Plus a fraction. 772300,000. Oh shit, it's correct. Could be wrong. I mean, if you have 7722, this is 10,000s, man. This is a tens, hundreds, thousands, 10,000s. Tens, hundreds, thousands, 10,000s. I'm recording. Okay. So 1, 2, 3, 1, 2, 3, 4. It's 4 zeros, so 1, 2, 3, 4. Cool. Express a pointed number as both a fraction and a decimal. One, two, each tick marks a 10, right? 1, 2, 3, 4. No, it's 100. It's the pitch marks. So fractions can be 1 point. 1, 2, 3, 100. Shit. Then let's say 4.03. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.1, 3. 3 over 300. Expanded form. Standard form, it's going to be like 4.402. 4.402. 4, 0.4002. 4 and 402 thousandths. 42, 42. 402 thousandths. Oh no, what is this question? Oh god, what is this question? No, I'm gonna take a pee. Woo! Right, back and back. So, I'm really getting confused by this question. I felt a lot of this during the practice. This one is so confusing. What does this even mean? it wasn't taught in any of the videos, but I can tell that 1 divided by here, right? 0 times then it's 10, 3, and then like 9. Then let's go. If it keeps on repeating like that, and the closest that I can get is this guy. I think this just pretty means that this is repeating. Is that what it meant? Could be. Okay, cool. Alright, 252 minus 200, 25.2 minus 18.5. Let's see. 25.2 minus 18.5. It's going to be 12, and this is going to be 14. The 1, and they're both going to knock each other out. We have 7 here, and this is 14, and we have 6. 6.7, right? So, I mean, if I add 6.7 to 18, we should get 25.2, so like 12, and then it's going to be like 7, 15, and 25.2, 6.7. Select the written form of each number. What's this? Just 1 meter. This 100, this 110. 100, it's not it. It's not it either. 100, it's right. It's 110. Represent the expression. Okay. This is going to be 980.7 thousands. 980.007. That's right. This is 1,000. 980. 900 plus 80. And if this was like 7 times 100, it's going to be 7. If it's 710, it's 0.7. So that would be the percentage, right? Woo! Let's go. 10 more questions. 8.3. One time, it's going to be 8.3. What is a rounded to the nearest 10? Okay. This looks like a is 14.38, something like that. Yeah, this one's 100 each jump here. What is a rounded to the nearest 10? Nearest 10 is this guy. So we're gonna have like 14.4. What's a rounded nearest to the nearest 1? It's 14, right? Let's think about this again. A rounded to the nearest 10. These are 10. We have like, we're quite 4 and 3. If it's 10, it's closer to this guy. 14.4, I guess. I'm pretty sure it's correct. Right? Let's think of it again. 14.4. 3 closer. Nearest 10 is 10. What is a round nearest 1? It's 1. And I guess we're gonna round down because it's still 14, it's not gonna round up. Yeah, it's correct. It's correct. Woo. Without using the calculator, dude, I've never used a calculator in the whole time I've been doing academy. Work fraction. Fraction. 5, so it's 0 times But in 30 it goes like 6 times, so 30. So it's 6. Shit. I'm going crazy. 3 divided by 5. So it doesn't go in that. Go in 30 like 6 times. Each large square is a whole. So we have 80 divided by 8 is going to be 10. Right? I mean, uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which point on the number line represents 0.59? Okay. So this one's a jump of 100. No, actually this is 1,000, 5,000. Or 6, 159 is going to be B. Point B. Damn, getting better. We go to school tomorrow. Venice takes a horse to the train. In total journey 6 minutes. Okay, 19.33 plus 2.37. Let's confirm. 19.33 kilometers and a train of 2.27 kilometers. 2.27. So we have 10. That's 6, right? 4, 6, 11, 21, 6, 3, 7, 10, 6, 9, and 11. This much. This makes sense to me. Express the location of the point of the number that is both a fraction and a decimal. One, 2, 3, 4, 5, 6, 7, 8, 9. It's by 10, so 1, 2, 3. Fraction will be 3 over 10. I don't want to fuck this up, so let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This by 10. It's the 3 divided by 1, 2, 3, and then 0.3 for the decimal part. Yeah. Oh, we're so close. Find the sum. 0.13 plus 0.3, 3, 4, 3, sum, right? You mean sum, so it's 4. It's making me paranoid. Last question. Oh shit. Okay, let's go. Divided by 62. Okay. 45.2 divided by 62. Okay. 1, 2, 62, and then 1, 2, 2,145. Because that times 0 times, but I'd say this is about 8 times. 6, 6, 18, so 19. Let's get 14, with 10, so I die. 14 is going to be 8. And then for this guy, it's 10, we have 1, 152. So we have 185, so it's just going to be 2, right? So 2 times 62, we have 4, and then like 12, we have 1, 6. Okay, makes sense. And then 2. Let's say 9. 6, 1, 2, 9. Yo, 9. Gonna be 18. 1. 8. 54, 55. 12 and plus 10. 12, 4, 5, and 54. 540. Let's say system spot. No, yo, let's write this. Uh, 1004.2 divided by 60. 2145.60. So 3 times here. 3, 6, 18. Right? Okay. 6, 18, 14, 10. 14, get 8, 10, get 2, and then we got 5. So for this one, we can do 4. Okay, 4. 8 and like 4. Yo, different answer from the previous one. 7 and 3. Let's bring down this guy. If I try 5, but I try 6. Let's do 5. 10, 30. Let's go 6. 6. 12, 36, 37. Oh, wow, it's been nice. 370. Okay. If we try to reverse this, I think we have 946 times like 16. 12, 8, 9, 6, and then we have 6 times 6, 36. 24, 27, 18, 20. What's the number? 6, 2, 15, 7, 14, and then, wait, what? Not 14, and 1, and then 2, yeah? 17, 14, 1. And then we're gonna 1 some point. 2, 1, 4, 5, 2, 1, 4, 5, 1. Oh, so we have 34.6. Right? Yo, 34.6 is the answer, man. Nice. Ah, my heart is pounding. Mastered. Oh, mastered. Let's go. Damn, it's 1:40 a.m. in the morning. God damn, heart's pounding. I don't know. It's amazing. It's amazing. So I'm recording for freaking 4 hours now. This is easy, man. It should be 100 now. It's like 5 now. So after the first song, see, arithmetic, we have 100%. So it's from 85 to 100. So let's see. Okay, same thing. Cool. Okay. God damn it. It's intense. It's pretty intense, man. It should be 100 now. Cool. Okay. So after that, let's see the missions. The World of Math for 18%. So glad I continued. Just finished it. So I'm done with arithmetic, and for tomorrow would be like my part 10. I believe this is the ninth session, part 9. So part 10, I'm going to start with algebra, and I had 42%. Cool, okay. Well, that's it for today, so thanks, bye.